We're in.
Shall we play a game?
How about global thermonuclear war?
Hey there, HackerFrogs. It's me, the Shy Hat, and it looks like we do not have our avatar online right now, so I'm just going to turn off my avatar and then turn it back on. Let's see if this works. Okay, come back, and here we are. Okay, that's great. Wonder what that little hiccup was all about. Anyways, we're here to do HackerFrogs AfterSchool. We're here to do HackerFrogs free hacking. We're hacking all the things. Cypher 3966 channel report. What are you talking about? Could you let us know what this is all about? Let me know. Anyways, all right. So what are we going to be doing today? So today is Friday, May 15th, 2026, and we're doing through, what was it, 4 different topics today. So the first topic we're going to be doing is we're going to be doing topic number 1, which is AI basics. We're working through a AI course because we need to learn more about these. And Wild Radio Root, hello, nice to see you here. We are HackerFrogs. We are indeed. If you're interested in taking the same course that we're taking a look at today, and this is going to be the first hour of today's stream, you can find the link over here. The second hour, we're going to be doing a Hack My VM grind. So this is a series of little challenges that we're going to be taking part in, and that's going to be over at the hackmyvm.eu website over here. That's going to be the second hour of today's stream. And Cypher says, I was joking. What would you report my channel for? We're not doing any illegal hacking over here, but how are you doing, Cypher? Anyways, okay, so the topic that we're going to do for the third topic is going to be HackerFrogs AfterSchool Digital Forensics. We're going to be doing more with Wireshark today, and we're going to be taking a look at how to investigate packet capture files with Wireshark, and that's going to be the third topic of today's stream. Okay, and SysOS, hello, nice to see you here. What is up? What is up? And the last thing we're going to be doing today is we're going to be taking a look at TryHackMe's Dirty Frag lab. So Dirty Frag is a recently discovered vulnerability, and we're going to be taking a look at that vulnerability through the TryHackMe platform over here. Hopefully they can shed some more light on how the vulnerability works and how to defend against it. And that's what we're going to be doing for the fourth topic of today's stream. So without further ado, let's go ahead and set an hour on the clock and get started with the first topic for today's stream. So just a second while I manually click on the number of minutes we want to set our timer for. Okay. And let's go ahead and get started. So this is going to be, we're talking about neural networks today. So neural networks, this is part of our Elements of AI course, and this is what we're going to be doing for the first hour of today's stream. Ignifer, hello, nice to see you here. What is up? What is up? So neural network topics. So the last time we were talking about the Elements of AI course over here. Okay, let's see. Join from car, no worries. Only type when standing still. Yeah, keep safe, SysOS Master. Nobody needs to get into any accidents while watching my stream. Okay, so neural networks. This is something that has to do with AI, and apparently they're trying to model AI in the same kind of way that they model human brains. So they talked about neurons, cell bodies and signals, dendrites, axons, and synapses. These all are very biology-heavy kind of terms, but these also have to do with the neural networks that they're creating with AI, apparently. So anyways, let's go ahead and move on to the next section. So what we're talking about here is why develop artificial neural networks. And before we get started here, I might as well put on a little bit of music, because it's always nice to have some music on in the background while we do our studying. So let's put on some, I mean, we can stick with the Muramasa soundtrack over here. I'll just make sure that it's a little bit softer than it was before. Okay, no seeing yet. Yeah. Definitely don't distract yourself if you don't need to. Okay, so why develop artificial neural networks? The purpose of building artificial models of the brain can be neuroscience, the study of the brain and the nervous system in general. It is tempting to think that by mapping the human brain in enough detail, we can discover the secrets of human and animal cognition and consciousness. Okay, so we're talking about artificial neural networks, we're talking about its relation to biological neural networks. So we're talking about modeling the brain. The BRAIN initiative, led by American neuroscience researchers, is pushing forward technologies for imaging, modeling, and simulating the brain at a finer and larger scale than before. Some brain research projects are very ambitious in terms of objectives. The Human Brain Project promised in 2012 that the mysteries of the mind can be solved soon. After years of work, the Human Brain Project was facing questions about when the billion euros invested by the European Union will deliver what was promised, even though, to be fair, some less ambitious milestones have been achieved. Okay, Wild Radio says it's a very dangerous space to venture into. I mean, I'm sure that if we study the brain with enough detail, or in enough depth, we'll be able to understand a lot more about how to improve our quality of lives. Okay, so however, even while we seem to be almost as far from understanding the mind and consciousness, there are clear milestones that have been achieved in neuroscience. By better understanding of the structures and the functions of the brain, we're already reaping some concrete rewards. We can, for instance, identify abnormal functioning and try to help the brain avoid them and reinstate normal operation. This can lead to life-changing new medical treatments for people suffering from neurological disorders, epilepsy, Alzheimer's disease, problems caused by developmental disorders or damage caused by injuries, and so on. MK Ultra territory. I don't know about that. We're more talking about neural networks as far as modeling them with computers is concerned. Okay, note, looking to the future, brain-computer interfaces. One research direction in neuroscience is brain-computer interfaces that allow interfacing with the computer by simply thinking. The current interfaces are very limited, and they can be used, for example, to reconstruct on a very rough level what a person is seeing, or to control robotic arms by thought. Perhaps someday we can actually implement a thought-reading machine that allows precise instructions, but currently they belong to science fiction. It is also conceivable that we could feed information into the brain by stimulating it by small electrical pulses. Such stimulation is currently used for therapeutic purposes. Feeding detailed information such as specific words, ideas, memories, or emotions is at least currently science fiction rather than reality. But obviously, we know neither the limits of such technology nor how hard it is to reach them. Like the show Leverage. I've never seen the show Leverage before. Can you tell me more about it? Okay, SysOS says, neural mapping is wild research. It's amazing and seriously interesting, but we can't run it anywhere near real time yet. Well, I mean, this is what the research is for, and this is what emerging technologies are for. We've drifted a little astray from the topic of this course. In fact, another main reason for building artificial neural networks has little to do with understanding biological systems. It is to use biological systems as an inspiration to build better AI and machine learning techniques. The idea is very natural. The brain is an amazingly complex information processing system capable of a wide range of intelligent behaviors, plus occasionally some not-so-intelligent ones, and therefore it makes sense to look for inspiration in it when we try to create artificially intelligent systems. Okay, so neural networks have been a major trend in AI since the 1960s. We'll return to the waves of popularity in the history of AI in the final part. Currently, neural networks are again at the very top of the list as deep learning is used to achieve significant improvements in many areas such as natural language and image processing, which have traditionally been sore points of AI. Okay? True, but we are now at a level of fruit of a fruit, not a human. The level of a fruit, as far as artificial intelligence is concerned, maybe. So what is so special about neural networks? The case for neural networks in general as an approach to AI is based on a similar argument as that for logic-based approaches. In the latter case, it was thought that in order to achieve human-level intelligence, we need to simulate higher-level thought processes, and in particular, manipulation of symbols representing certain concrete or abstract concepts using logical rules. Okay, we have entered peak nerf territory. Nerf territory? Let's see. Oh, AI is so new. It's from the 1960s. Okay, we're at the level of a fruit fly, not a human, as far as mapping this stuff is concerned. Okay. All right. So the argument for neural networks is by simulating the lower level sub-symbolic data processes on the level of neurons in neural networks, intelligence will emerge. This all sounds very reasonable, but keep in mind that in order to build flying machines, we don't build airplanes that flap their wings, or that are made of bones, muscle, and feather. Likewise, in artificial neural networks, the internal mechanism of the neurons is usually ignored, and the artificial neurons are much often simpler than their natural counterparts. The electrochemical signaling mechanisms between natural neurons are also mostly ignored in artificial models, where the goal is to build AI systems rather than to simulate biological systems. Compared to how computers traditionally work, neural networks have certain special features. Neural network key feature number 1. For one, in a traditional computer, information is processed in a central processor, aptly named the Central Processing Unit, or CPU for short, which can only focus on doing one thing at a time. The CPU can retrieve data to be processed from the computer's memory and store the result in the memory. Thus, data storage and processing are handled by two separate components of the computer, the memory and the CPU. In neural networks, the system consists of a large number of neurons, each of which can process information on its own. Talking about popular music, aren't we? NERF is an acronym. Oh, interesting. What is NERF an acronym for? Key feature number 2. The second difference is that data storage, that is memory and processing, isn't separated. Huh. That's weird. It looks like my stream got taken down on Twitch and on YouTube. Man, these I've been having some problems with my connectivity. Okay, anyways, let's keep on going. So the neurons both store and process information so that there is no need to retrieve data from the memory for processing. The data can be stored short-term in the neurons themselves that either fire or not at any given time, or for longer-term storage in the connections between the neurons. NERF is an acronym. It means Neural Radiance Field. Neural Radiance Field. I haven't heard that one. Yeah, I'm not super familiar. Okay, so let's see. Or for longer-term storage in the connections between the neurons, there are so-called weights, which we will discuss below. Because of these two differences, neural networks and traditional computers are suited for somewhat different tasks. Even though it is entirely possible to simulate neural networks in traditional computers, which was the way that they were used for a long time, their maximum capacity is achieved only when we use special hardware, that is, computer devices that can process many pieces of information at the same time. This is called parallel processing. Incidentally, graphics processors, or graphic processing units, or GPUs, have this capability, and they have become a cost-effective solution for running massive deep learning methods. Okay, Wild Ready Root says, like Gaussian blur in digital art, but extremely precise military-grade stuff. I mean, this is why we're studying about AI and the way they train AI right now is that we need to better understand this technology, because we're going to be hearing increasingly more about AI as time goes on. Okay, so the next section is how neural networks are built. Let's take a look. Okay, so how neural networks are built. As we said earlier, neurons are very simple processing units. Having discussed linear and logistic regression in Chapter 4, the essential technical details of neural networks can be seen as slight variations of the same data. And Marcello Paz, hello, nice to see you here. Nice to see you here. Hope you're having a good Friday. So we got weights and inputs. The basic artificial neuron model involves a set of adaptive parameters called weights, like in linear and logistic regression. Just like in regression, these weights are used as multipliers on the inputs of the neuron, which are added up. The sum of the weights times the inputs is called the linear combination of the inputs. You can probably recall the shopping bill analogy. You can multiply the amount of each item by its price per unit and add up to get the total. Okay, so if we have a neuron with 6 inputs, analogous to the amounts of the 6 shopping items, potatoes, carrots, and so on, we'd have input 1, input 2, all the way to input 6. We also need 6 weights. The weights are analogous to the price of the items. We'll call them weight 1 up until weight 6. In addition, we'll usually want to include an intercept item like we did in linear regression. This can be thought of as a fixed additional charge due to processing a credit card payment, for example. Okay. So we can then calculate the linear combination like this. Linear combination equals intercept plus weight 1 times input 1 plus weight 2 times input 2 all the way up until weight 6 times input 6, where the ... is a shorthand notation, meaning that the sum includes all the items from term 1 to 6. So with some example numbers, we could then get a sample equation over here. So let's go ahead and investigate this. So over here, let's make a directory for all the stuff that we're going to be doing today. So I'll call this one the chatting text editor, and we'll give this a fancy color. Let's make it brown, and we're just going to create a file called chatting.txt that we're going to work inside of. So what we're looking at right now are these, all of these items right here. So this equation, it's a kind of a weird place to. Okay, so we've got an equation over here. It is, so this is the intercept. So the intercept is going to be added to, what was it, input 1 times weight 1 times input 1, and then weight 2 times input 2, and then all the way up until input 6, and then we get our final calculated value over here. Okay, and we need to do a little exercise. So exercise 21, weights and inputs. In this exercise, consider the following expression that has both weights and inputs. Okay, so this is exactly what we looked at up here. Okay, and what is the intercept item, the intercept term in the expression? So we were told that the first thing that we need to include in the expression is the intercept, and the intercept would be this one over here, item B. Okay, so what are the inputs? So the inputs and the weights are different things. So we would have input times weight. So input is 5.4, and then minus 10.2, and then minus 0.1, and then 101.4, etc., etc. So let me just make sure. Intercept plus weight 1 times input 1. Oh, I got it mixed up. So the first number in each pair is the weight. So the input is the second number, which means that this is a weight, this is a weight, this is a weight, and this is a weight. Okay. So the weights are 8 and 5 and 22. 8, 5, 22, minus 5, 2, and minus 3. Okay, let me just make sure that these are the correct numbers. Minus 3, 2, minus 5, 22. Okay, so it looks like it should be item A over here. Okay, which of the inputs needs to be changed the least to increase the output by a certain amount? Which of the inputs needs to be changed the least to increase the output by a certain amount? Okay, so the inputs over here are all correlated with weights. So we need to look at the number with the largest weight. So this is a weight, this is a weight, this is a weight. Hold on. Let's identify the weights over here first. So this is a weight, this is an input, 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 and then down here, this is a weight, this is an input, weight, input. Okay, so the one with the largest weight is this one right here, so it's 104, 101.4, and this is associated with the input minus 5. So because the weights are large, they affect the result the most over here. So the input minus 5 or the weight 101.4 should be the answer. So which of the inputs? Okay, so the first, second, third, or fourth. If we take a look here, they're looking for inputs. So this is first, second, third. The fourth input in this case is the one associated with the largest weight. Weights are sometimes floating point, but does that mean that inputs are never floating point? I mean, and it doesn't seem to be. All of these inputs seem to be integers, and the weights are sometimes floating point, it looks like, yeah. Okay, so it looks like the fourth one needs to be changed the least to increase the output by a certain amount. Okay. And what happens when the fifth input is incremented by 1? What happens when the fifth input is incremented by 1? Alright, so let's take a look at the fifth input. So 1, 2, 3, 4, 5. If we increment the input here by 1, it becomes 3. But because it's being multiplied by 0, that means that nothing should happen. Okay, so the answer should be A. Okay, and then we'll submit. Did we get all the answers correct? Okay, we got all the answers correct. The math is mathing. Great. Okay, we'll move on. Okay, the weights are almost always learned from data using the same ideas as in linear or logistic regression, as discussed previously. But before we discuss this in more detail, we'll introduce another important stage that a neuron completes before it sends out an output signal. Okay, so we're talking about activations and outputs. Once the linear combination has been computed, the neuron does one more operation. It takes the linear combination and puts it through so-called activation function. Typical examples of the activation function include identity function. do nothing and just output the linear combination. Step function. If the value of the linear combination is greater than 0, send a pulse on, otherwise do nothing off. I mean, when I think of neurons, I think of just this function right here. So neurons are either firing or they're not firing. So they're kind of like a binary operation. So they're either on or off. But we've also got this, what is this? Sigmoid function, a soft version of the step function. A soft version of the step function. Note that with the first activation function, the identity function, the neuron is exactly the same as linear regression. This is why the identity function is rarely used in neural networks. It leads to nothing new and interesting. Okay? So let's see. How neurons activate. Real biological neurons communicate by sending out sharp electrical pulses called spikes, so that at any given time, their outgoing signal is either on or off, a 1 or a 0. The step function imitates this behavior. However, artificial neural networks tend to use activation functions that output a continuous numerical activation level at all times, such as the sigmoid function. Thus, to use a somewhat awkward figure of speech, real neurons communicate by something similar to the Morse code, whereas artificial neurons communicate by adjusting the pitch of their voices as if yodeling. Yeah, that is kind of an awkward figure of speech. Anyways, we'll move on. Okay, so I think we're going to be talking about self-driving cars here. The output of the neuron, determined by the linear combination and the activation function, can be used to extract a prediction or decision. For example, if the network is designed to identify a stop sign in front of a self-driving car, the input can be the pixels of an image captured by the camera attached in the front of the car, and the output can be used to activate a stopping procedure that stops the car before the sign. Learning or adaptation in the network occurs when the weights are adjusted so as to make the network produce the correct outputs, just like in linear or logistic regression. Many neural networks are very large, and the largest contain hundreds of billions of weights. Optimizing them can be a daunting task that requires massive amounts of computing power. Okay, looks like we need to do another exercise. So exercise number 22, activations and outputs. Below are graphs for 3 different activation functions with different properties. First we have the sigmoid function, then the step function, and then finally the identity function. Important, note that the different y-axis or vertical scales in the identity function chart. Okay, so the different vertical, so this is horizontal, this is vertical, and we're taking a look at the identity function chart. So this is sigmoid. Sigmoid of output. So as the input grows closer to 0, then we see a gradual rise up until the input becomes just slightly over 4, and then it reaches the plateau here. So the input number here versus the sigmoid output here. It approaches 1, it starts at 0. Okay, so that's the sigmoid output. The next one is the step function output. So this is either going to be a 1 or a 0, so it's either on or off. So at the point where input becomes 0, then the step function output goes from 0 to 1, and then it plateaus there after the input exceeds the number 0, or equals or exceeds the number 0. But while the input is less than 0, then the output is, well, the step function output is 0. Okay, and we've got the identity output, and the identity output looks like a straight correlation between input and identity output over here, starting at -10, -10, and so it's kind of like what is it called? Proportional. So the input equals the identity output over here. So input equals output. Okay, so which of the activations described above gives the highest output for an input of 5? Which of the activations described above gives the highest output for the input of 5? So we need to take a look at the input of 5. So we've got identity output, so 5 equals 5. 5 equals 5 for identity. For step function, 5 equals 1. And for sigmoid output, 5 equals 1. So I guess the answer has to be the identity output. Okay, so this one is identity. The lowest output for an input of -5. The lowest output for an input of -5. So if we look here, -5 is -5 in the identity output. So -5 equals -5 for identity. -5 equals 0. -5 equals 0 for step function output. And -5 equals 0 in sigmoid output. So if the question is the lowest output for an input of -5, it has to be the identity, because this is the only output that has negative numbers. So identity output has negative numbers, but the other ones, actually the other ones do too. No, the output is always, the identity output can be negative, but the step function output and the sigmoid output don't go any lower than 0. Okay, so the third question is the highest output for an input, the highest output for an input of -2.5. Okay, so once again, we'll take a look at the 3 charts. So -2.5, we're looking for the highest output. So -2.5 is about here. So we're looking for the highest output. So here it's -2.5, -2.5. Here it's -2.5, 0. And here it's -2.5, but it's more than 0 here. So the answer has to be sigmoid output. Okay, let's see if these are the correct answers. Okay, so we got all 3 of these correct. The identity function will give an output of 5 for an input of 5. Okay, so the lowest output for an input of -5. The identity function will give an output of -5 for an input of -5, and the sigmoid output something very close to 0, and the step function will be exactly 0. Okay, so we got those answers correct. Let's see, Defus asks, what's up with your Twitch stream lately? It's lagging all the time, and sometimes it resets completely. It was like last time as well. Yeah, this week I've been having some problems. I've been having some problems with the connectivity of my live stream. I'm not exactly too sure what's going on. After this stream is over, I'll probably be doing some troubleshooting on that. But thanks for bringing it to my attention, Divas. I need to figure out what's going on with my internet. Or if it's not my internet, then it's going to be something to do with the software or whatever services I'm using. Okay. Anyways, the next thing is Perceptron. Perceptron, the mother of all ANNs. So the perceptron is simply a fancy name for the simple neuron model with the step activation function we discussed above. It was among the very first formal models of neural computation and of its fundamental role in the history of neural networks. it wouldn't be unfair to call it the mother of all artificial neural networks. Okay, SysOS says, I've seen the same issues with more streamers. It might be something on Twitch's end. I mean, I'm not completely sure because it seems to be affecting both Twitch and YouTube. For me, every once in a while we'll see spikes. So spikes in the amount of data that's going through. So it might be something on my end. Okay, so let's see. Perceptron can be used as a simple classifier in binary classification tasks. A method for learning the weights of a perceptron from data, called the perceptron algorithm, was introduced by the psychologist Frank Rosenblatt in 1957. We will not study the perceptron algorithm in detail. Suffice it to say that it is just about as simple as the nearest neighbor classifier. The basic principle is to feed the network training data one example at a time. Each misclassification leads to an update in the weight. Okay, so we got AI hyperbole. Zero Services Game of Thrones reference? Game of Neurals? Game of Neurals. Are you talking about the stream title? Or something else? Okay, so AI hyperbole. After its discovery, the perceptron algorithm received a lot of attention, not least because of optimistic statements made by its inventor, Frank Rosenblatt. A classical example of AI hyperbole is a New York Times article published on July 8, 1958. The Navy received an embryo of an electronic computer today that it expects will be able to walk, talk, see, reproduce itself, and be conscious of its existence. So this is way back from July 8th, 1958. In 1957, imagine how advanced it would have been at that time. Yeah, I mean, hyperbole is all about making things to be way more important than they actually are. So please note that the neural network enthusiasts are not at all the only ones inclined towards optimism. The rise and fall of logic-based expert systems' approach to AI had all the hallmark features of an AI hype, and people claim that the final breakthrough was just a short while away. The outcome both in the early 1960s and late 1980s was a collapse of research funding called an AI winter. So people have been doing all sorts of AI research from way back when. What we see right now is just like a culmination of everything from the past. So the history of the debate that eventually led to an almost complete abandoning of the neural network approach in the 1960s for more than 2 decades is extremely fascinating. The article, A Societal Study of the Official History of the Perceptrons Controversy, by Michael Alazarin, published in Social Studies of Science in 1996, reviews the events from a sociology of science point of view. Reading it today is quite thought-provoking. Reading stories about celebrated AI heroes who had developed neural network algorithms that would soon reach the levels of human intelligence and become self-conscious can be compared to some statements made during the current hype. If you take a look at the above article, even if you wouldn't read all of it, it will provide an interesting background to today's news. Consider, for example, an article in the MIT Technology Review published in September 2017, where Jordan Jacobs, co-founder of a multi-million-dollar Vector Institute for AI, compares Geoffrey Hinton, a figurehead of the current deep learning boom, to Einstein because of his contributions to development of neural network algorithms in the 1980s and later. Also, recall the Human Brain Project mentioned in the previous section. According to Hinton, the fact that it doesn't work is just a temporary annoyance, although according to the article, Hinton is laughing about the above statement, so it's hard to tell how serious he is about it. The Human Brain Project claims to be close to a profound leap in our understanding of consciousness. Doesn't that sound familiar? Okay, thank you very much for updating me, says Master. No one really knows the future with certainty, but knowing the track record of earlier announcements of imminent breakthroughs, some critical thinking is advised. We'll return to the future of AI in the final chapter, but for now, let's see how artificial neural networks are built. Okay, so putting neurons together, networks. Okay, Moha, hello, nice to see you here. I want you to try hacking a chatting gameplay. A chatting gameplay? I'm not exactly sure what a chatting gameplay is. Can you be more specific about that? Are you talking about like AI chatbots or something else? Okay, so a single neuron would be way too simple to make decisions and predictions reliably in most real-life applications. To unleash the full potential of neural networks, we can use the output of one neuron as the input of other neurons, whose outputs can be input to yet other neurons, and so on. Sick in the mind, hey, nice to see you here. Shablo World? Shablo World is the name of the game? Shablo World. I mean, I'm not too sure what that is. Is that some sort of online game? Okay, where was I? The output of the whole network is obtained as the output of a certain subset of the neurons, which are called the output layer. We'll return to this in a bit after we discuss the way neural networks adapt to produce different behaviors by learning their parameters from data. Okay, so what are these layers? Often the network architecture is composed of layers. The input layer consists of neurons that get their inputs directly from the data. So for example, in an image recognition task, the input layer would use the pixel values of the input image as the inputs of the input layer. The network typically also has hidden layers that use the other neurons' outputs as their input, and whose input is used as the input to other layers of neurons. Finally, the output layer produces the output of the whole network. All of the neurons on a given layer get inputs from the neurons on the previous layer and feed their output to the next. So Shablo World, yeah, this seems to be something. Is it something political? Anyways, we don't deal with politics on this stream. So a classical example of the multi-layer network is the so-called multi-layer perceptron. As we discussed above, Rosenblatt's perceptron algorithm can be used to learn the weights of a perceptron. For multi-layer perceptron, the corresponding learning problem is way harder, and it took a long time before a working solution was discovered, but eventually one was invented. The backpropagation algorithm led to a revival of neural networks in the late 1980s. It is still at the heart of many of the most advanced deep learning solutions. Meanwhile, in Helsinki, so remember that Helsinki is in Finland, the paths leading to the backpropagation algorithm are rather long and winding. An interesting part of the history is related to the computer science department of the University of Helsinki. About 3 years after the founding of the department in 1967, a master's thesis was written by a student called Seppo Linenmaa. The topic of the thesis was cumulative rounding error of algorithms as a Taylor approximation of individual rounding errors. The thesis was written in Finnish, so this is a translation of the actual title, something that I'm not going to try to read. Okay, SysOS Master says it's Oh, okay. So it's a Flash game. Interesting, okay. Alright, so the automatic differentiation method developed in the thesis was later applied by other researchers to quantify the sensitivity of the output of a multi-layer neural network with respect to individual weights, which is the key idea in backpropagation. Alright, so we're looking at a simple neural network classifier. To get a relatively simple example of using a neural network classifier, we'll consider a task that is very similar to the MNIST digit recognition task, namely classifying images into two classes. We will first create a classifier to classify whether an image shows a cross, an X, or a circle, or O. Our images are represented here as pixels that are either colored or white, and the pixels are arranged on a 5x5 grid. In this format, our images of a cross and a circle, more like a diamond to be honest, look like this. Okay, so we've got a 5x5 grid, and the pixels on the 5x5 grid are either supposed to represent a cross or a circle. In order to build a neural network classifier, we need to formalize the problem in a way where we can solve it using the methods that we've learned. Our first step is to represent the information in the pixels by numerical values that can be used as the input to a classifier. Let's use 1 if the square is colored and 0 if it is white. Note that although the symbols in the above graphic are of a different color, green and blue, our classifier will ignore the color information and will use only the colored or white information. The 25 pixels in the image make the inputs of our classifier. So to make sure that we know which pixel is which in the numeric representation, we can decide to list the pixels in the same order that you'd read text. So row by row from the top, and then reading each row from left to right. So the first row of the cross, for example, is represented as 10001. The second row as 01010, and so on. The full input for the cross input is this. So it's just a big string of binary numbers separated by commas. Okay, so we'll use the basic neuron model where the first step is to compute a linear combination of the inputs. Thus we need a weight for each of the input pixels, which means 25 weights in total. Okay, Victor86 says, state-sponsored hacking is legal or a gray area? State-sponsored hacking is legal in the country where the state-sponsored hacking is happening, and it's illegal everywhere else. So what's legal in... So if you're in the United States and you're doing state-sponsored hacking, then it's legal in the United States, but illegal everywhere else. But yeah, I mean, it might not be that black and white, but it's essentially that black and white. So your white hat hacker in one country that's a state-sponsored hacker is a black hat hacker from the perspective of every other country, or at least the countries that they're hacking into. Okay, finally we use the step activation function. If the linear combination is negative, the neuron activation is 0, which we decide to use to signify a cross. If the linear combination is positive, the neuron activation is 1, which we will decide to signify a circle. So let's try what happens when all of the weights take the same numerical value 1. With this setup, our linear combination for the cross will be 9. 9 colored pixels, so 9 times 1, and 16 white pixels, 16 times 0, and for the circle image will be 8. Say 8 colored pixels, 8 times 1, and 17 white pixels, 17 times 0. In other words, the linear combination is positive for both images, and they are thus classified as circles. Not a very good result given that there are only 2 images to classify. To improve the result, we need to adjust the weights in such a way that the linear combination will be negative for a cross and positive for a circle. If we think about what differentiates images of crosses and circles, we see that the circles have no colored pixels in the center of the image, whereas crosses do. Likewise, the pixels at the corners of the image are colored in the cross, but white in the circle. We can now adjust the weights. There's an infinite number of weights that do the job. For example, assign weight -1 to the center pixel, the 13th pixel, and weight 1 to the pixels in the middle of each of the 4 sides of the image, letting all the other weights be 0. Now for the cross input, the center pixel produces the value -1, while all the other pixels, either the pixel value or the weight is 0. So -1 is also the total value. This leads to activation 0, and thus the cross is correctly classified. So how about the circle then? Each of the pixels in the middle of the sides produces the value 1, which makes 4 times 1 equals 4 in total. For all the other pixels, either the pixel value or the weight is 0, so 4 is the total. Since 4 is a positive value, the activation is 1, and the circle is correctly recognized as well. Okay, Victor86 says, is one government allowed to hack another country in international law? International law? I mean, I'm not too sure how international law factors into nations attacking each other electronically. Yeah, I'm not an expert on that. It's something that you might want to look up over there. So happy or not, we'll now follow similar reasoning to build a classifier for smiley faces. You can assign weights to the input pixels in the image by clicking on them. Clicking once sets the weight to 1, and clicking again sets the weight to -1. The activation 1 indicates that the image is classified as a happy face, which can be correct or not, while activation -1 indicates that the image is classified as a sad face. So don't be discouraged by the fact that you will not be able to classify all the smiley faces correctly. It is in fact impossible with our simple classifier. ZSOS says that there is no strict international law that dictates it, but if it's disruptive, it's generally perceived as a military action. Yeah, I'm not. I think I'll avoid talking about this particular topic. Alright, so this is one important learning objective. Sometimes perfect classification just isn't possible because the classifier is too simple. In this case, the simple neuron that uses a linear combination of the inputs is too simple for the task. Observe how you can build classifiers that work well in different cases. Some classify most of the happy faces correctly, while being worse for the sad faces, or the other way around. Can you achieve 6 out of 8 correct for both happy and sad faces? Okay, so happy faces classified correctly, and sad faces classified correctly. Okay, what is this? Let me adjust my music, and then we'll keep on going. We only have... Wow, we've been studying for a while, huh? Okay, so happy faces and sad faces. So we can actually see that these are the happy faces that they're looking for, and these are the sad faces that they're looking for. So we need to... So it looks like an important thing for the sad faces is that for the sad faces, there are some that have... Oh. Huh. There are also happy faces that occupy the corners here as well. But in most cases, the happy faces don't occupy these over here. So let's see, what's the objective again? The weight to 1 and -1. So -1 is a sad face. So this is a sad face. So if there are pixels in these corners here, this means that we've identified these as happy faces. So the other thing is that when we take a look at these happy faces here, These on this row are usually associated with these happy faces with the upturned smiles like this. And what else? So what other... I'd say that most of the time, if there are pixels here, here, or here, then these are associated with happy faces as well. If we take this to the kind of like conclusion, we would say that if there are pixels here, here, and here, that also means that these would be sad faces. But these don't pick up these happy faces. So maybe we can say that... yeah, we're trying to identify happy and sad faces. So I guess we can also look at these as happy faces. Although it's kind of rare that the happy faces come up here. If we say that there's... yeah, this isn't a very good indication of happy faces. So let's do... so we'll do neither happy nor sad for... so this will be weight 0. I think this is about as good as we can get. Because adjusting these other weights here, well, okay, we got this as a happy face. That's just one more though. So 5 out of 8 happy faces and 4 out of 8 sad faces. So we want to find like a happy medium where we have the most number of happy faces and sad faces classified correctly. Can you achieve 6 out of 8 correct for both happy and sad faces? 6 out of 8. So I think we've got... no we don't. 6 out of 8 correct for both happy and sad faces. How else can we adjust these weights? We have 5 identified correctly here, but only 4 here. So it looks like none of the sad faces have a pixel in the middle at the bottom. So we'll classify this as a 1. So we got 5 out of 8 and 4 out of 8 here. Is AI not fun? Well, we're just trying to figure out what's going on. It would be too popular if more people knew about this channel. That's fine. Let's grow our audience organically. So let's see. So we've identified these happy faces. We need one more happy face to be correctly identified, here. So these identify 7 out of 8 happy faces, but they don't identify the sad faces very well. So we need to modify our weights so that it picks up on more of these sad faces. So sad faces usually have So now we've got 5 out of 8 happy faces and 4 out of 8 sad faces that are being identified correctly. So this one doesn't make any difference. So usually the corners, usually the ones, so the bottom row is usually associated with these sad faces. Yeah, I can't, well, I mean, we don't really need to submit this. Or maybe it activates when, or maybe it counts it as completed when we actually get the right thing. We only have a few more seconds left on our topic, so maybe we'll just move on to the next section. All right, so let's talk about what we're going to be covering next. So originally we were going to be covering some PicoCTF exercises, but I didn't have enough time to prepare all my slides. So what we're going to be doing instead is we're going to be trying to solve this challenge over here called Hack My VM Grind that we can find over here. So if you don't have an account over at hackmyvm.eu, you can make one for free and you can join along with us. Normally computers kind of brute force this anyways. Yeah, I think we'll be we'll be skipping it. Anyways, we've got 60 minutes on the clock for our next topic. So the next topic is going to be this one. So topic 1 is done, topic 2 is here, and topic 3 is on deck. Alright, so the next challenge where we're going to be doing is over at Hack My VM, and this is part of Hack My VM Grind, which is a series of challenges that usually cover the same kind of topic. So it looks like we're going to be dealing with database leaks in this particular exercise. If you have an account and you want to join along with us, this is the exact challenge we're doing over here. We're going to be spending the next 60 minutes trying to solve this challenge. So it says, "Hi Shyhat, one of our friends has obtained a database leak. We need your help to get the information. We got a file that we can download." So while we're solving this, we'll also be working on a write-up for it as well, so that we document how we solve the challenges. So this is going to be walkthroughs for Hack My VM. And this one is called HMV Grind. So I'll just make a new directory for this. And this challenge is called Coin. So we'll record a few things about this: the URL where we can find the challenge, the concept we need to understand to finish the challenge, and the method of solving the challenge. Okay, so we'll be filling this in as we go. We don't know what the concept is yet, so let's go ahead and get started. I'll call this my HMV Grind terminal tab over here, and we'll give it a fancy color. How about some blue? Okay, so what do they want us to do? I think they wanted us to download a file. So download file. Let me know if you can download this file while not logged in. Because, I mean, it's a lot easier if I can share the challenges with y'all if you don't need to be logged in, you don't need to have an account. So we'll try a private. Okay, so you can download it even if you're not logged into the HackMyVM site. The Bread, hello, nice to see you here. So, alright, so we need to unzip the file, and then we need to answer the questions. So how many unique users, case sensitive, are there? Unique files. So I guess we need to unzip this thing first. So I'm just gonna... What's the name of the file? It's like coin, right? There it is. Okay, move into the current directory and then unzip the thing. So it's a DB file or database. So usually when we run the file command on it, it'll tell you what kind of database we're dealing with. And in this case, we're dealing with this SQLite 3.0 database. So SQLite is one of the many flavors of SQL, the database management system that that is used by a lot of web apps and such. But anyways, SQLite 3. So we can run the SQLite 3 command on our Kali Linux over here to access the database. So it looks like we're just going to be doing some database forensics. So I guess we can fill this in here. So concept, database, forensics, SQLite, system interaction. Sure, let's call it this. Okay, so the first thing we want to do is we want to figure out what commands we want to run on the system. I'm pretty sure that most of the SQLite commands all start with the dot. So it's like dot tables, dot something something. So dot tables. So we got a bunch of different tables in here. We've got logins, message, metadata, transactions, and users. So I think the first thing we want to do is we want to take a look at the users table here. So we want to get information about the users table. Although I guess we could, if we really wanted to, we could just output everything from the users table with a very simple... Thank you very much, Pones World, for subscribing on YouTube. Thank you very much. We could do something like select star from users, and that would get us all the information from all the columns in the users table. That's a lot of users. That's a lot of users. Okay, so the first question is to just get the number of users, right? Method of solve. We need to use SQLite commands to interact with the database file and get the answers to the questions. Okay, the Bread says the .schema command is useful to show all of the tables and columns and their types. Yeah, I think we should, I mean, we should be keeping track of the different commands we use as well. So let's see. Question 1. So we've got a bunch of questions. Question 1, question 2, well, I mean, you know. So question 1 is, how many unique users, case sensitive, are there? How many unique users? Why would we care about case sensitivity when the answer is supposed to be, a number? Huh. Anyways, we'll copy paste this. So to answer this question, use the SQL Lite 3 program to interface with the database file. So that would be this command here. It's SQLite 3 coin.db. Okay, what type of hacking is Dirty Frag? Well, if you want to learn about it beforehand, you can learn all about it over here. We're going to be going through the room in the 4th hour of today's stream. Okay, so use the SQLite 3 program to interface with the database file. From here, we need to use SQLite syntax to find the information we're looking for. So the first thing that we would run is the .tables command, and this lets us know there is a users table. So the second thing we should do is figure out the columns in the users table Yeah, it's a Linux privilege escalation hack, Josh Lee. Okay, so let's go back. So in here, it looks like we've got like ID, username, and then like email, and then date registered or something like that, but .schema for users. So .schema for users lets us know what kind of columns exist. So there's user ID, alias, email, and signup date. So user ID. So it looks like there are 150 users. But yeah, the next command we run is this. And finally, we can just get the count for the user ID column. And that should return the number of users. So there should be like a count function. Ganik, hello, nice to see you here. Looks like I missed the party. Was there a party? We were just doing our warm-up. The only thing you really missed was the warm-up. Okay, so what we need to do is we need to figure out what the count function is in SQLite. SQLite count function. So in SQLite, the count function is an aggregate tool used to return the total number of items in a group or rows in a table. Return the number of items in a group or rows in a table. So the number of rows in the table. So in this case, we could just run count on users. Error here. Count users. Am I supposed to capitalize this? Oh, or are we supposed to use like select count? No, it still doesn't like this. Okay, do we have an example here? Syntax and usage. Select count from table name. Oh, okay. Select count from table name. I mean, I guess it would have to be select count user ID from users. Okay, so this works. So this is the command we're looking for. Okay, you need to select count column. Count distinct email might give a different result. Oh, you know what? You're right. So what they're asking for is how many unique users, case sensitive, are there? So unique users, select count So let's see. So unique users, I think. So it says it's case sensitive. So you've got user 19139, user 140. We need to make sure that all these are all like distinct, right? So we need to find the method we could get distinct. Select count all or distinct. Count distinct from. Okay, let's try select count distinct and user ID from users. No, not user ID. We're actually looking for the email. Okay, it doesn't like this. Use distinct. So use distinct. So it's select. So how do we use the distinct keyword in this case? Count every row in a table. Okay, count unique departments. Select count distinct. Okay, so we don't use we use the distinct keyword inside of count, and then we don't use a comma here. Use pipe instead of comma. Yeah, in this case we don't want the so distinct email from users. Great. Okay, so it looks like we've got a different answer now. So select count distinct email from users. And we got 145. So let's try submitting this as the answer to see if it's correct. So 145. Access granted. Okay, so we can move on to the next thing. Use pipe instead of comma. Can we use the pipe there? So if we go here, so it's distinct. It doesn't like that. It doesn't like this. I mean, we can just. So this is the command that gets us the information we want. So we'll record this. And Thames Coder, hello, nice to see you here. Okay, so let's go back. So finally we get the count for the email column in this case. And use the distinct filter. And that should get us our answer. Okay, so question 2 is what? It appears the credits are corrupted. It appears the credits are corrupted, but you must find the total sum of those successfully transferred. GX00, thank you very much for the Prime sub, and nice talking to you over at the InfoSec meetup yesterday, GX000. Nice to see you. And let's give you your favorite redeem. the frogs.
Mud. Flies. Mud. Mud. Flies. Mud. Flies. Mud.
Hope you're having a good day.
Mud. Flies. Mud. Mud. Flies. Mud. Flies. Mud.
Alright, so it's break time because there's ads running on Twitch right now, but I'll put on the birds while we take a little bit of a water break. Okay, so here's a lovely northern flicker woodpecker. We'll be back in about 30 seconds, just need to take a little water break. Okay, we'll put the birds away, we'll get back to the hacking. Is he trying to break something? All I see is him pecking, not eating. Yeah, I mean, these woodpeckers have to peck everything into like small bites before they get eating. So they're going to be breaking up the peanuts before they eat the peanuts. Okay, so what we're doing right now is we're doing some database forensics. Did I know? Is there something that you need to tell me, UX000? Bird is the... Did I know that bird is the word? Bird is the word. Have you heard that bird is the word? So it appears the credits are corrupted. You must find the total sum of those successfully transferred. The credits are corrupted. You must find the total sum of those successfully transferred. So it looks like we're going to be doing some... some more database investigation here. So the tables, there's logins, message, metadata, and transactions. So I'm guessing what we need to do is we need to take a look at the transactions table. So we'll take a look at the schema for the transactions table here. So we got TXID, we got user ID, amount, date, and status. So I'm guessing that we need to select amount and date from the transactions table. Okay. You know, it's kind of funny that some of these have the euro symbol, but some of them don't have the euro symbol. So I don't know how to treat these. So actually, we don't actually want date, we just want the status. Amount status from transactions. So we got failed and completed. What we need to do is we need to filter out the failed transactions, right? Okay, so let's talk about this. So over at our write-up, it appears the credits are corrupted. You must find the total sum of those successfully transferred. So we need to look at the transactions table. So looking at the transaction table means that we need to look at the schema for the transactions table and figure out which columns we're interested in. So we're interested in looking at the what are the two? The amount and the status columns. So it's amount. So we're looking at select amount status from transactions. Yeah, select amount status from transactions. We see some of them are completed and some of them are failed. And we're only interested in the rows where the status is completed. So we need to refine our filter. So select amount status from transactions where status not failed. So does this work? Okay, so not failed. Maybe we would put in something like this. Yeah, okay, that's what we want. So we want status not equal to failed. So we only return the rows where it is not failed. Actually, do we want... So there might be like another... We only want completed. We want completed, but we don't want anything else. So maybe what we should do is we should filter by completed. Where status is equal to completed. Okay, this is more accurate. What? Just a second, everybody. Let me switch over my music. I detected some... Okay, let's continue with this music. Alright, so completed. You can check what possible values of status there are. Select status from transactions group by status. Group by status? Okay, maybe that's what we should be doing. Select status. Yeah, thank you very much for that. So I will, of course, steal it from you. Okay, so we're only interested in rows where the status is completed, but before that, we should get the possible status values, and that's where this one comes in. So select status from transactions group by status. So we're only interested in the rows where the status is completed. So select amount status from transactions where status is equal to completed. Okay, completed sounds right, but there might be something else. Buffering fairy is angry, is it? I really need to do some investigation as to what's going on with my upload. With my upload rate on the stream. Okay, so we got completed, we got status, and then we just need to get a sum of all of these. It said stream disconnected from me too. Now it's back. Yeah. Yeah, I need to do some diagnostics. Okay, so Select amount status from transactions where status equals completed. So we're looking at the correct rows, but we have to sum all of the numbers in the amount column. So I'm pretty sure that there should be like a sum function inside of SQLite. So SQLite sum function is an aggregate function that returns the total number of all non-null values in a column or expression. So I think we might come across a problem because some of these have the euro symbol and some of them do not have the euro symbol. Select sum from table name or condition something something. Select from transactions. So it's going to be sum of what was it? Amount. From transactions where status is equal to completed. Okay, we got this really big number. I'm not too sure if this is the correct number or not, but we can submit this as the flag, see if it works. If it doesn't, then, well, we'll have to go from there. Access denied. Okay, so that wasn't it. Alright, so it appears that the credits are corrupted, but you must find the total sum of those successfully transferred. Okay, so Dubred says select euro euro 1, euro 2. Euro 1 plus euro 2. SQLite has the replace function. You could remove the euro by replacing with an empty string. Okay, so let's see. If we're gonna do the replacement, then we have to we'd have to do the replacement. Select some amount from transactions where status equals completed, and we'd have to put it in here. Replace. But how would we run that inside of this function here? Okay, let's just do a little search. Sum function with replace function. You can combine the sum and replace functions to perform arithmetic on string data that needs cleaning first. This is most commonly used to remove symbols like currency signs or commas before totaling a column. To sum a column where we're removing or replacing specific characters, use replace inside the sum function. So we got select sum replace. Ah, okay. So we just need to put this in the middle of the sum function. So I guess it would be replace amount, string to remove, and the string to remove is the is the euro symbol. So euro symbol, replacement is empty string, replaced with nothing from transactions where status equals completed. So let's see if this gives us a different... It does give us a different sum. No, it gives us a much larger sum. It gives us a much larger sum. So this is probably what we're looking for. Okay, let's go back in and we'll submit this as the answer. See if it works. Access granted. So that was correct. Okay, so let's update our write-up here. So looking at the correct rows, we need to sum all the numbers in the amount column. But we also need to replace all of the euro symbols with empty strings to make all the input consistent. Okay, so we'll copy the command that we just did. So select sum, replace something something. Okay, so that's done. So we can move on to question number 3. So question 3 is, what is it? What is the ID of the user who has generated the most successful transactions? What is the ID of the user who has generated the most successful transactions? Okay, so let's go ahead and copy the question and put it in a write-up. So what is the ID of the user who has generated the most successful transactions? Okay, so we're working inside of the same table here. So we're looking for the ID, the most successful transactions. We don't care about the actual amounts. We only care about the number of transactions that are completed. So select, well, first of all, we should probably refresh ourselves on what columns exist in transactions. .schema transactions. So you got TXID. So TX, I'm guessing this means transaction ID. And then we've got the user ID. And we got the status. So we need to pay attention to user ID and status. So for this question, need to pay attention to the user ID and status columns in the transactions table. Okay, so I guess here what we would do is we would do select user ID status from transactions where status is equal to completed. This just gets all of the ID numbers here. So I guess what we could do is we could order them. Shulk Wyzek. Hello, nice to see you here. What is it? What is up? What is up with you? So we got. It has been a while. It has been a while. Yeah, yeah. So we're currently doing database CTF challenge over here. We're looking through some SQLite tables. It's like order by. Order by user ID. So if we order by user ID, no, they don't like this. Okay. So what we need to do is we need to get the counts. So let's see. What we need to do with SQLite here is we need to sum the number of entries, number of rows with identical values. So to sum the number of rows with identical values in SQLite, use the group by clause alongside with the count aggregate. Group by? Oh yeah, right, group by. Yeah, we used that previously. So it's group by user ID. Group by user ID just gets you the unique user IDs. But what we need to do is we need to select column name, count as row count. Count as row count. From column name, from table name, group by column name. Okay, so if we were to adjust this to our circumstances, then it'd be something like group by user ID. I believe if you count table name, it will work fine. If you count table name. So Amen Bench, hello, nice to see you here. Select user ID, count amount from transactions, group by user ID. I mean, I'll try your solution, Amen, see if it works. Where were we? Select user ID count amount. I mean, we're not looking for amount, we're just from transactions. Group by user ID. Oh, hold on. Okay, it counts rows. It counts rows per group, so you can specify anything as the count parameter. Yeah, I forgot to include my my semicolon. Okay, so select user ID count. Ah, okay. So I guess we need to where status equals completed, because we're only interested in the ones where it's completed. Where status completed. Error here. Oh, okay. We need to order this differently. We need to put it where status equals completed here, and then group by user ID on the other side. Okay. And then we need to put in descending by descending order by column name. Order by. So go in here, order by count amount. So let's see. Where statement came only before the group. There should be one distinct answer here. Is this a CTF or what? Yeah, it's a CTF. It's this over here. Okay, select user ID, count amount. Actually, we shouldn't count the amount. We need to count the... We're not counting the amount in this case. We're counting the status. Count status from transactions where status equals completed. Group by user ID, order by count status. Huh, this is the same thing though. We get the same numbers. There should be one distinct user ID that stands out here. Select user ID, count TXID. TXID from transactions grouped by user ID. We're counting transactions. Yeah, we need to count the transactions, but we also need to count we need to count only the completed transactions. So if we do are the groups that we expect, try a specific UID. So user ID, user ID count TXID from transactions group by user ID. So if we just give this, then it gives us the count of the transaction IDs. The count of the transactions IDs from transactions grouped by user ID, but we also need to put the where clause, where status is equal to completed. And then we need to group these by descending. Thank you very much for following Campy Barra. Thank you. Status equal to completed, group by user ID, order by count TXID. I think we need to order by descending. No. We order by the count TXID. These are all giving us the same numbers though. There has to, because the question implies that there's one user who has generated the most successful transactions. What is the ID of the user that has generated the most successful transactions? Maybe multiple correct answers? I mean, generally in CTF challenges, there are not multiple correct answers. There's usually just one answer. Just pick one? I don't think that's the way we wanna play it. Okay. So if we just do it like this, let's do a little bit of debugging, I guess. So just get the status where user ID status from transactions where status equals completed. So we need to order these. Order by user ID. Okay, we see most of these users have 3 completed. So is there, I mean, let's take a look at the question one more time. What is the ID of the user who has generated the most successful transactions? So that points us towards the transactions table. And successful transactions means that we need to take a look at the status. And the status has to be completed. That means it's successful. Okay, which roadmap are you following to learn about cybersecurity? Any guidance? Amen Bench, hey, we've got a funky little website over here called Get Into Cyber. And it has a lot of links and videos with advice talking about how to get into cybersecurity. You might want to take a look at that. What is the ID of the user who has generated the most successful transactions? So here, what we've done, I mean, let's see if we can eyeball this first. Okay, so order by user ID. So if we order by user ID, maybe we order by count user ID. No, doesn't like this. Maybe we have something beyond completed. Something beyond completed. Okay, so have you practiced kernel and rootkits? I mean, kernel stuff we cover occasionally. Rootkits not so much. So kernel exploits are something that, well, I mean, kind of like what we were talking about over here. We're going to be talking about the dirty Frag vulnerability that came out like last week, was it? And we're going to be doing that later on today. It's like kernel exploits are not something we talk about too often. So you got login, message, metadata, transactions, and users. I wonder what's in the... It has to be the transactions table that we're looking at, though. Yeah, so we just need to... So we're not looking at transaction IDs. We're looking at user IDs. So we're selecting user ID from transactions where status is equal to completed. Now if we just do it like this, but then we just get the user IDs. But what we want to do is table to see the structure of all the tables. I mean, I think we've got everything we need. You could use SQLite Master table to see the structure of all the tables. I mean, I definitely think we're dealing with the right table in this case. It's the transactions table. So these are just the user IDs over here from the transactions table. So we need to get the the total number right here. Let's just try. So we're asking over here to count occurrences of identical values in SQLite and order them descendingly. Use group by combined with count and order by. This approach identifies unique values and counts them, and then sorts the results with the highest counts appearing first. Okay, so let's just we'll try analyzing what our good friend the AI has given us here. So Hanky, hello, nice to see you here. What is up? Select so we got something that looks like this. Wait a minute, could I see the transaction table enumeration in the users? Transaction table enum. Hold on. So it's like .schema transactions. So we got TXID, user ID, amount, date, and status. We're only interested in the rows where the status is equal to completed. So status is text, user ID is integer, amount is text. And users? Users is user ID, alias, email, and sign up date. So yeah, we're definitely dealing with the transactions table. Select column name. So we'll try select. We're looking at user ID count as frequency from table name, and in this case it's going to be the transactions table. group by column name, in this case it's user ID. Order by frequency. Frequency descending. I mean, descending is default. So we might be looking at something like this. Okay. Man, it's still giving us the same number. There can't be... There's probably not multiple correct answers, because there are all these user IDs that have the number 4. Wait, are we supposed to do like some sort of join? Or like a union select? Got our user IDs here. Yeah, I think we're gonna have to come back to this because we're running out of time. But the thing is when we take a look, we just order by user ID. We see that all of the users basically have the same, well, they have very similar numbers of completed transactions. Pick one that you like, group by, then list the user ID. Order by user ID. Okay, so let's see. Aman Bench says select user ID from transactions where status. Select count user ID from transactions where status equals completed. I think that would be a good like debug, just to make sure that there's a distinct answer from here. Count user ID. Well, we need distinct user IDs, right? This is weird. Select user ID, count where status equals completed. This comes out as 2 and 438. Guess we can't use count user ID in this case. So maybe count everything. Nope. Forgot the group by. Select count user ID from transactions where, let's see, I believe we need to join here because the user names are in the users table and the transactions are in a separate table. So without join, we wouldn't know who made the transaction. Yeah, I was thinking that we might need to do a join in order to get the correct information. So if we take a look at the we just get everything from users. Select star from no. Did I spell something incorrectly here? Select star from... Oh, no, we need from users. Okay. So the thing is that in the users table, it's user ID and then alias and then email. The user ID is... The user ID, there's the same user ID in the users table as there is in the transactions table. So yeah, there's user ID here and there's user ID here. And they should correlate with each other. Okay, try out select user ID count C from users, order by C descending limit 1. Can give it a try. $54. I mean, the thing is if we don't limit it to 1, there's multiple users who have the same number, which kind of points me towards the fact that there's no correct answer here. Anyways, we kind of ran out of time for this exercise. Try to submit the ID. I mean, this is 50? Yeah, this is not the correct one. It's okay. We'll come back to this. We'll come back to this later. But for right now, we'll save out what we have for our write-up, and we'll come back to this later because we need to do the next topic. So the next topic is HackerFrogs AfterSchool. We're going to be doing some Wireshark stuff, some network PCAP forensics, and let's go ahead and get started on that. No worries, no worries. It's just that we have to stick to our schedule. Okay, so this is going to be for forensics. This is the 4th session. Alright. So everybody, if you want to take a look at all the links for all the exercises we're going to be using in this workshop, they're in the chat right now. So, hey everybody, this is HackerFrogs AfterSchool. And I should probably change out my overlays. Just a second. So we're doing topic 3 right now. Topic 4 is on deck. Let's get some real stuff. Okay. We're doing HackerFrogs AfterSchool. We're doing digital forensics. We're taking a look at Wireshark. This is part 2. So Shulkwysek, if you want to take a look at the same stuff we're looking at, let me go ahead and give you the link, okay? If you wanted to give this a try yourself, this is the zip file for the database, and this is the challenge link over here. Feel free to try it out yourself if you want to continue with the challenge. But, okay, so this is Wireshark Part 2. Hey there, HackerFrogs. This is the 4th intro to Digital Forensics Workshop. In the previous workshop, we learned about the following digital forensics concepts. We learned about network traffic. Anytime a network device sends data from one device to another, network traffic is generated as network packets are sent back and forth. We talked about PCAP files. Files which contain a collection of network traffic are called packet capture or PCAP files, and one specialty of digital forensics is the analysis of network traffic in PCAP files. Okay, Victor86, is this knowledge dangerous in the hands of the malicious? Well, I mean, these are just a set of skills. So I like to think of it as like a knife. You can give a person a knife and they can use it to do good things, or you can give a person a knife and they can use it to use bad things. So the skills in and of themselves are not good or bad. It's the intentions of the people who are using the skills. So PCAP files, yeah. The next thing is Wireshark. So Wireshark is a program which is widely used for network traffic analysis, and we're going to learn how to use it to analyze PCAP files. So packet capture files, we will analyze them using Wireshark. And in this workshop's topics, we're going to be doing some Wireshark practice with the TryHackMe Carnage room. So the TryHackMe Carnage room is over here. If you've got a free account over at TryHackMe, you should be able to access this room. So let's begin our Wireshark practice with the TryHackMe room, and it's over here. So what you want to do after you've logged into TryHackMe and navigated to this link is you want to go over to task number 1, and you want to start the machine. So this particular room comes with a virtual machine that you can use to interact with it. So in task 1, click on the green Start Machine button over here, and that should start up the virtual machine that we're going to be using to solve today's workshop. So let's go ahead and read a little bit more about what's happening here. So we're not super concerned about the story, but it says here, Eric Fisher from the purchasing department at Bartel Limited has received an email from a known contact with a Word document attachment. Upon opening the document, he accidentally clicked on Enable Content. The SOC department immediately received an alert from the endpoint agent that Eric's workstation was making suspicious connections outbound. The PCAP was retrieved from the network sensor and handed to you for analysis. So the task for today is to investigate the packet capture and uncover the malicious activities. Okay, so note, do not interact directly with any domains and IP addresses in this challenge. That's good. Okay, so let's see. Amen's bench says, whenever I try to get into CyberSet, I get lost very quickly and don't find more info to proceed. I get lost very quickly and don't find more info to proceed. I mean, the first thing you want to do when you want to approach the task of trying to find a role to work with inside of InfoSec is to figure out which kind of InfoSec, which kind of cybersecurity is best suited to you. Because there's a bunch of different roles, and the first thing you should do is you should identify what you like to do or what you would like to do in cybersecurity, whether or not that's Security Operations Center analyst, or network pen tester, or web app pen tester, if that's a digital forensics analyst, or if it's going to be incident response. There's a bunch of different jobs, and the jobs all have very different training. So the first step is to figure out what you want to aim for. Okay, so what we want to do after the machine initializes like this is we want to put the virtual machine in its own browser tab. So you can do that by going to the center of the screen and then go down to the bottom, and there's a button that's labeled View in Full Screen. So what you want to do is you want to go down and press that button, and that's going to open up the associated virtual machine that we're going to be using today and open it up in full screen. So what you want to do from here is you want to click on the analysis folder over here, because that's where our PCAP file is. We do this. Hold on, let me put on some new music. Oh, it looks like my offline again. Darn it. Yeah, the stream seems to be coming. The traffic is really bad. My connection seems to be coming up online and offline. It's not great. Okay, the YouTube stream is back online, but I'm just waiting for the Twitch stream to come back online. Okay, looks like the Twitch stream is back online as well. Yeah, it's been a rough stream. It's been a rough stream, and we've had all sorts of weird hiccups. All right, so we've got our Wireshark working here. You didn't notice anything, okay? Yeah, it looks like we're working with a bit of a buffer for some of this as well. Okay, so we got our Wireshark program here. I can maximize it. Yeah, it seems to be maximized already. So this is going to be kind of rough because it seems like the resolution on the virtual machine monitor seems to be a bit wonky. I wonder if I can increase the resolution on this. So desktop properties. Okay. Because the interface seems to be, the resolution seems to be too low. Desktop settings, properties. Maybe I can search up resolution. Or like screen resolution. Display. Okay, resolution 960 by 4. Yeah, this is way too low. I'm gonna need at least, let's try 14 by 1050. This still seems to be pretty low. Okay, is there any way to turn off recording now? Light on the laptop without breaking it? Turn off the recording now without breaking it. I mean, well, I mean, the recording's back. I'm not too sure if they're going to separate this into separate VODs or not. That'd be a bit of a big pain in the butt. 1920 by 1080. Can we do this? No, this doesn't seem to change anything. Yeah. Wireshark. Because I really can't work with this. This is not very fun. And I can't even see the hexadecimal view from here. I wonder if we could change the zoom on this. So zoom. Oh, this works. Okay, this is much better. Anyways, it's super fun to do troubleshooting. So it turns out that if your resolution is too low on your virtual machine desktop, you can go into the zoom on your web browser. I had this issue the other day in QEMU, and Kali's solution was to update and restart the box. Maybe that will help you. I think we've got it handled here now, but let's see if I can make. We can make the text bigger here. Okay, that's good. Okay, I think we're all right now. So people don't know that they're being recorded. People don't know they're being recorded. I typed that before you found the Zoom. Okay, no worries, no worries. People don't know they're being recorded. I mean, if you participate in a live stream, it's pretty much assumed that if the live streams are going to be archived, then the people who are participating are being recorded. I mean, if you don't want to be recorded, don't type anything in chat, and your messages will not be recorded. Okay, let's go ahead and start the room. Yeah, all the live streams are recorded. I mean, I've got my local copies as well. Okay, so what we're going to do is we're going to click on this. Well, in task 1, you can click on task 1 to complete it, and we're going to be answering some questions over here. So the first question is, what was the date and time for the first HTTP connection to the malicious IP? So the first thing we need to do is we need to find the malicious IP in the first place. So we go back. Okay, we need to change the zoom in all these things. Okay, so the first thing we would need to do is we need to identify what the malicious IP is in the first place. And let me see if I can find something in my notes. Okay, so the first question is, what was the date and time for the first HTTP connection to the malicious IP? So the first thing we want to do is we want to pay attention to the HTTP packets. What room is this? So this is the Carnage room, and it is over here. Over here. Okay, so what we're going to do is we're going to go into the display filter here, and we're going to filter by HTTP packets only. So after we do that, it'll tell you at the bottom over here in the Wireshark display. So the packets, it says that there are like 70,000 packets, but there's only 364 displayed. And you can find the number of the packets at the bottom of the Wireshark interface. And what we need to do next is we need to, I think these are all ordered by time in the first place. So if we adjust the columns, we get the number of the packets, the time, and in this case, we're looking for what is the date and time for the first HTTP connection to the malicious IP. So if we're assuming that the first HTTP packet is the first connection to the malicious IP, then we can go into Wireshark here, and then we can take a look at the frame information. So the frame information has the arrival time of the packet, and we can right-click on it, and then select Copy Value. Copy Value will just get the date value for this particular item. If we go back, well, let's try to format this first. (2021) September is 10. Is September 10 or no, September is 9. Okay, so 9/24 hour, so that's 16. I mean, we can just copy this directly over here. So hour, minute, second. So we'll try submitting this answer as the first answer, well, for the first question over here. Check it. Okay, that is the correct one. The next question is, what is the name of the zip? What is the name of the zip file that it was downloaded? So we're looking for a zip file. So if we wanted to look for a zip file instead of Wireshark, what we could do is we could just look for the word .zip in the contents of all the packets. So we can disable the filter here, and then do Control F to look for a zip file. So in the display filter here, actually we're gonna not do display filter, and instead we're gonna select string. So it's Control F, and then in this drop down menu here, select string, and we're gonna select .zip. So .zip, this is gonna look inside of all the packets, and it's gonna look for any instance of the string .zip. In this case, we found one. So we found one here. This is documents.zip. So we can click on this. we can go down into the hypertext protocol. Or we could look for the magic bytes of zip, PK, I believe. I mean, there's a few different things. Twitch hiccuped again. Yeah. Hold on. So the YouTube stream is on. Yeah, the Twitch stream is on again, but it seems like we're going on and offline. The bitrate is not good. And this also gets us our documents.zip file. So it tells us which packet it's contained within. So we could click on this, request URI documents.zip, and we also have the data here as well. It's your not fault, it's just tech issues, we all have them. We all have the tech issues. Are you going live tomorrow? No, I'm not going to be going live tomorrow, but the next regular stream is going to be next week on Wednesday. So we have a schedule that we keep over at the HackerFrogs subreddit over here. So this is the schedule for next week. Twitch completely died for me. Yeah. I mean, the YouTube is healthy. The YouTube is healthy, but Twitch seems to be a bit laggy right now. I've been having troubles with both Twitch and YouTube, which makes me think that the problem is on my end and not their end. But yeah, that's the this is the schedule for next week. Okay, so over at TryHackMe, they're asking for the name of the zip file that was downloaded. So it's documents.zip. Check on this. Okay, so the next question is, what was the domain hosting the malicious zip file? So we're just going to move through the presentation file here. What was the name of the zip file that was downloaded? So we're illustrating here that we can use the export objects option in Wireshark to look for files that were downloaded in the PCAP file. And most files that are downloaded use the HTTP protocol. So we can do file, export objects, HTTP, and then it shows you that there's one file here called documents.zip. When you click on a particular file in the Wireshark object export list, it will select the associated packet in the packet list view. So we demonstrated that. So the next question is about the domain. So the domain hosting the malicious zip file is this one over here, attirenepal.com. Let's see, what was it? So this one over here, request URI. So this is inside of the packet details list. Why is this? Anyways, okay, so it's the answer here is attirenepal.com. So we can actually go back to the export objects list and click on this, and it tells you in the host name this particular domain. So attirenepal.com is the answer. So we're just going to copy that. We're going to go back to here. What was the domain hosting the malicious zip file? It is this, attirenepal.com. Okay, so the next question is, without downloading the file, what is the name of the file in the zip file? What is the name of the file in the zip file without downloading the file? So if we go back to Wireshark here, we click on this, close, and we look in the contents view, in the hexadecimal contents view here. If we scroll all the way down, we can see that the contents of the file are usually going to be inside inside here. So at the very end of the file, we see a file name. It's like chart1, chart-1. Is it chart-1? Hold on. Okay, so they want us to the name of the file in the zip file without downloading the file. So this should be in the data here. Okay, so the data, I think we could export this, but exporting it counts as downloading the file. Just a second, let me see if I can get some insight from past Shy-Hat. Okay, without downloading the file, what is the name of the file in the zip? So for zip files, the names of the files inside them are included in the file contents, which can be viewed through the packet bytes view in Wireshark. So the packets, oh, okay. So the actual name of this is this right here. So this number.xls. This number.xls. So we'll go back. And we'll scroll down to the bottom. So this particular name .xls, we'll right click on this, and then we'll copy bytes as printable text. So copy as printable text, and then we'll go somewhere and we'll paste this information. Say like right here. Oh, that's a lot of information. Okay, we can't. Most of this is not. It's pretty garbled. Okay, so what we'll do instead is we'll just copy the information, the name that we want. So the name that we want is this thing right here. It doesn't let us select it. Right click. Copy bytes as hex and ASCII dump. Copy as hex dump as escape string. So we'll do copy bytes as hex and ASCII dump, and we'll try pasting it again into our text document here. Okay, so this is what we're looking for here. We're looking for this number, chart this 1.xls. So this implies that it's some sort of spreadsheet file. Okay, so just highlight this entire name over here, and this is the name of the file. Well, then we'll go back to TryHackMe and we'll submit this as the answer. Check. Okay, that's the correct one. Xmetric says implication is misdirection. Implication is misdirection. I'm not too sure what we're referencing here. Okay, so the next question is, what is the name of the... Let me just type this into the chat. Okay, what is the name of the web server of the malicious IP from which the zip was downloaded? Sorry, let me just make sure that this is what we're looking for. Okay. What is the name of the web server of the malicious IP from which the zip was downloaded? It's the name of the web server. So what we're actually looking for here is we're looking for information from the HTTP headers. XLS implies that it's a spreadsheet. That's correct. Okay, so if we go back into the packet details view here, we can take a look at the at the HTTP response headers. So we see here hypertext transfer protocol, so this is HTTP, and we've got the different HTTP response headers. So X powered by, and what we're looking for in this case is we're looking for the server. So the server is listed as Lightspeed, and this is the answer that the question wants. So we can highlight this, select it, and then right-click, copy value, and that should copy the name of the server here. Okay, so this is Lightspeed. So back over at TryHackMe, submit Lightspeed as the answer. Okay, so what is the version of the web server from the previous question? The version of the web server from the previous question. So we're looking at the same packet in this case. So we're looking for a web server version. If we go back in here, it should be in the same response. So it's X powered by PHP 7234. It better not accept PHP. It better not accept PHP. So X powered by PHP. So once again, we'll select the value, or we'll select the line. We right click and then we copy the value. Copy the value, then go back to TryHackMe, and then get rid of the X powered by section. Okay, and then we got PHP 7234. Okay, that's what they're looking for. Because the real correct answer would be whatever version of Lightspeed that was running. Yeah, I understand. I understand that. It's just that it's a bit wonky. It's a bit wonky in this room. Okay, what was this version of the web server from the previous question? They're looking for the software version number for this question, and that's PHP. Okay, let's move away from the official questions. So there are more questions, but the official questions are actually kind of difficult. So we're going to be moving away from those, and we're going to be answering a couple of questions that I created for here. Where are we? Okay, so how many HTTP packets were sent from the source IP 10.9.23.102? So how many HTTP packets were sent from the source IP? So if we go back into Wireshark here, we can set up a little display filter. This has gotten too big. Here. Okay. All right, so what we're going to do is we're going to go into the display filter here, and then we're going to get HTTP packets. So if we filter by only HTTP packets, and then we want to filter by the criteria here. Okay, so let me just copy this over to the chat. So how many HTTP packets were sent from source IP 10.9.23.102? So in order to create multiple filters in the display filter, we need to, let's make this a little bit bigger. We do one filter, and then we do the double ampersand over here for another filter. So the other filter is going to be ip.source, and that's going to be equal to our IPN question. So it's 10.9.23.102. So we can combine these filters to get a more refined result. IP.source host. Oh, okay, okay, that's slightly different. So it's IP.source_host. Let's grab this. Go back to Wireshark and then apply the filter. No, that's not it. Okay, can you give me a free web page for CTF? What do you mean by free web page for CTF? I mean, we got a lot of stuff in our education resources. PicoCTF is one. I mean, PicoCTF isn't PicoCTF anymore. It's Scilab. If you haven't been keeping up, it's called Scilab Academy now. So scilabacademy.org. No worries, it's actually a pretty recent change. It's within like the last week or so. But what was formerly PicoCTF is Scilab now. So it's it wasn't like PicoCTF was bought up by Scilab. Scilab was always a thing that was associated with the same university. Okay, so once we apply the filter here, you can go down to the bottom and you can see how many displayed packets there are. So down at the bottom over here, we see packets 70,873, but displayed is only 105. So that's the answer for this question. Okay, and the last question here is this one. So there's a malware website called Find Jewels in the Packets. What is the full domain name? So this is the question here. So there's a malware website called Find Jewels in the Packets. What is the full domain name? So if we're looking for this particular website, I mean, Find Jewels is a pretty distinct string that we can look for inside of Wireshark. So if we go back to Wireshark and we get rid of the filter that we have already, we can do Control F to activate the search. And inside of the search window here, we can type in the word Find Jewels, and we can click on this and make sure that this is set to a string. So after that, click on Find, and we see that there's a DNS entry over here. So click on the DNS entry, and it says findjewels.com.au. So if we go down in here, actually let's make this a little bit bigger here. So under domain name system query, we can expand this. And we see here under queries, findjewels.com.au. And this is what we're looking for here. Okay, in TryHackMe you need a subscription. I mean, we're talking about PicoCTF, and for PicoCTF or Scilab Academy, everything there is free. So, and I mean, you're partially right when you say that TryHackMe needs a subscription. TryHackMe needs a subscription for some of their rooms, but not all of their rooms. Scilab Academy is good for beginners, yeah. Okay, so, but there's a lot of stuff on TryHackMe that's also free. All of the stuff that I cover on my channel that's from TryHackMe is free materials. There's definitely a lot of free stuff on TryHackMe. You just need to know where to look. Okay, so where were we? Okay, I think that's all we have for this particular room. Okay, so this is a bit of a shorter one, but I guess what we could do is we could talk a little bit more about some other resources for learning about Wireshark. So what did we learn today? We learned about exporting files from Wireshark. We can use the export objects option in Wireshark to look for files downloaded in the PCAP file, and most files are downloaded using the HTTP protocol. So if we really wanted to download this particular the spreadsheet file that we found, we could go back into Wireshark here and then click on File, Export Objects, and then HTTP. And then we could click on the documents.zip file. And then after that, after clicking on it, we can click on the save button. So save, we can save it anywhere we want. We'll save it to the desktop. Click on save, and then we should be able to access this file. So where's the desktop? The desktop is here. We got documents.zip here, and we can open this up, and we've got our chart. So assuming that this is not a password protected file, we could just drag and drop to get access to the chart here. And I'm not too sure if the chart actually has anything super malicious or anything. We could open it up. There's nothing to open it up with on this box. Okay, we don't have Microsoft Excel or anything. Okay, but yeah, it's a very, very useful feature of Wireshark to be able to download files that are inside the packet capture file. So anytime you see anything, so like a zip file, we can also look for we can search by content type and look for anything that looks a little bit unusual. So we got a bunch of text files. We also have we have got document.zip, and then a bunch of what look like base 64 encoded strings, which are kind of funny. All right. So what else did we learn? We also learned about isolating IP addresses. So we can apply more than one display filter at once, and this is a good way to isolate traffic coming from specific IP addresses. Most of the time when you want to look up specific display filters in Wireshark, you can usually search for them. So for example, Wireshark display filter by source IP address. You could usually get the answer pretty quick. But if you find yourself looking at the same display filters again and again, what I would recommend is I would record the syntax of whatever display filter that you're using often, and then put them inside of a document, so some sort of notes, so that you can keep track of them. Okay, so we'll go back. Oh, wrong file. So isolating IP addresses. So the next thing another thing that we took advantage of is searching for strings in packet contents. So the search function in Wireshark can be very useful for searching for specific text strings in packets. For example, if you wanted to look for a special string like .zip or find joules, the name of some domain, you could look for the specific string and then select string contents when you're doing your display filter or the search query. Okay, so next time when we do our next digital forensics workshop, what we're going to be doing is we're going to be taking a look at digital disk image forensics with PicoCTF. So digital disk forensics is taking a look at disk images and finding all the little secrets within them. So that's going to be a lot of fun, and that's going to be on Wednesday of next week. But since we've got a bit of time, we got about 15 minutes left, I might as well point you towards another good place to look for Wireshark practice. So if you want to do more practice with Wireshark, then the allacyber.it website over here is a very good resource. The website's in Italian, of course. Well, this is allacyber.it, which means it's Italian. But if you're using the right browser, you can auto-translate everything on the website. So this is it's a good website for learning about basics on a bunch of different topics, including packet capture. So packet capture exercises are listed on this website under the network security category. Okay, are BMX bikes still cool for 40-year-olds? I mean, if your mobility is still good at 40. I mean, I'm not saying that you are a decrepit old man at 40. I'm over 40 by a good amount. But I mean, if your knees and your legs are okay, then I'd say it's okay. Then I'd say it's fine. So they've got a bunch of different exercises over here that are good for learning about particular parts of Wireshark. So if we go into our web browser extension here, we can translate the page from Italian to English. Okay, for example, it says here, in this challenge, in this series of challenges, you'll be introduced to some issues necessary to solve challenges related to network security. Okay, to solve this challenge, you need to understand what a file is, what the PCAP file is, and how to analyze it. So among the various ways to analyze PCAP files, a great way with the graphical interface is Wireshark. So if you've got access to your own virtual machine with a bunch of cybersecurity tools, what I recommend is to get a virtual machine that can run the Kali Linux distribution for you. So I've got if you're looking for how to install that on your host machine, I've got a video on YouTube that talks about that. I'll leave the link in the chat. Okay, Victor86 says, I don't climb stairs. I don't climb stairs. This is reverse results for what I wanted. Worse knees. I thought less stairs would be good for knees. Well, I mean, the important part is that you don't overstrain your knees earlier in life. That's the best way to ensure that you don't have horrible knee problems later in life. Okay, so I'm pretty sure. Okay, let's go ahead and shut down our virtual machine on TryHackMe because we're not using it anymore. So we will open the split view and then we will shut down the machine. So click on terminate machine down here. And then we're done. Okay, so like I said, allacyber.it is a very good resource for learning about Wireshark and PCAP forensics. Another good resource is PicoCTF. So PicoCTF over here, well, it's Scilab Academy now. So just create an account over at Scilab Academy. If you have a login for PicoCTF, you should be able to use the PicoCTF login as well. And what they have here is they've got a bunch of resources for PCAPs as well. So if you click on Learn and then Challenge Library, and you search for Forensics, Wireshark. So they got a couple of challenges over here. I think they've got more than one Wireshark challenge, and there's a number of like learning paths here as well. Let me see if I can find one that has good stuff for PCAPs. So learning paths, all learning paths. Let's see. Let me see if I can find one real quick. Python and CTF's Vault Door series. So there's a bunch of a learning path is basically a bunch of linked like a group of challenges that is good for learning about a specific topic. Let me see if I could find what I am looking for. It doesn't look like it doesn't look like they have a series for Wireshark, but here's a link if you want to take a look at those two challenges, or like Wire. If you just look for Wire, Shark on Wire, and Wireshark, so there's 4 challenges here that you might want to look at. Okay, so what we're going to do is we're going to start our next topic earlier. And let's go ahead and do that. So topic 3 is done, topic 4 is here. And if we finish up with topic 4 early, we'll do an extra topic. But we'll try to spend about an hour doing our last, well, our quote-unquote last topic today, which is going to be talking about the dirty frag vulnerability. Okay, so if you want to join along with us, this is over at TryHackMe, and it's a free room on TryHackMe. So once you've logged into TryHackMe and you've navigated to this link, what you want to do is you want to click on the Join Room button. So this particular part of the live stream is we're going to be taking a look at the dirty frag Linux privilege escalation exploit, which was discovered very, very recently, like within the last 2 weeks. So click on Join Room. Fun. Yeah, I hope it's going to be fun. So I hope I get to learn a thing about the Linux kernel. It's going to be a lot of fun. Okay, so after you've joined the room, then we got Task 1 Introduction. So to successfully complete the room, you need to set up your virtual environment. This involves starting the target machine, ensuring you're equipped with the necessary tools to access and tackle the challenges ahead. So under Task 1, there's a green button labeled Start Machine. We want to click on that. And that's going to start up the virtual machine that we need to use to learn more about this particular vulnerability. So Riyadh Gamer says, I've learned Python and want to learn networking and play CTF so I don't get burned out. I want to learn networking and play CTF so I don't get burned out. So SysOS says, remember this is like the copy fail bug room from the other day. Yeah, it's related, from what I've heard. So Riyadh Gamer, what I would say is I'd check out some CTF challenges, and there's also a lot of good links at the Get Into Cyber thread over here. Okay, so let's talk about this vulnerability. So it says here, Dirty Frag is a vulnerability class that chains 2 separate Linux kernel bugs to gain root on every major distribution. The 2 bugs sit in unrelated subsystems, but they share an identical underlying pattern, and chaining them lets a single exploit binary cover the blind spots that would otherwise stop each bug individually. This class was discovered and reported by Vabel. I'm not too sure how to pronounce this. Some user on Twitter, maybe? Okay, so the 2 component vulnerabilities are xfirm, ESP, page cache write, or CVE 2026, this number, in the IPsec ESP input path, merged to the netdev tree on 7th of May 2026, and accepted in the main line on the 8th of May 2026 as commit this number. Merged in the netdev tree on May 2026. This was very recently. Okay, this plan could cause me to get distracted. I mean, you need to know what you want to, where your goal is. If you don't know where your goal is, you can't be focused on that goal. So what I would say is you need to come up with a plan. Maybe a little, you need to at least know where the end goal is. So what you want to become as far as cybersecurity is concerned. There are networking specific CTFs. Networking specific CTFs. What I would say is, okay, so Riyadh Gamer, you're talking about, I want to be a grown-up, of course. So you want to learn cybersecurity. Okay, you say you're learning Python. You want to learn networking. And you want to play CTFs. You don't want to get burned out. What I'd say is you need to figure out like a primary thing that you want to do. So for example, if your primary focus is learning networking, you need to study your networking until you can't study the networking anymore, and then do some other activities so that you can avoid burnout. So when you get tired of learning networking, you want to play some CTFs, or you want to maybe try some programming challenges with Python. And then after a break, you go back to networking and you study some more, and then you repeat the process when you get tired of learning the networking. Okay, let's continue here. So we also have the RX RPC page cache write. So this CV over here from 2026. Reserved in the AFS RX RPC verify path, no patch exists in any tree at the time of disclosure. No patch exists in any tree at the time of disclosure. That's not great. Okay, so SysOS says, it was that or I want to be a hippie. I want to be a grown-up or I want to be a hippie. If you have completed the copy fail room, the underlying primitive will be familiar. Both copy fail and dirty frag write into the in-memory page cache of a file that the attacker only has read access to, and both bypass file integrity monitoring as a result. The subsystems involved differ, but the class of bug is the same. Switch between topics when you get tired of one topic. That'll help you avoid taking too many breaks. So if you take a break every time you get tired of a specific topic, your progress is going to be kind of slow. So what you should be doing is you should be switching between a couple of different topics when you get tired of one. Okay, dirty frag is named for the kernel structure it abuses, where dirty pipe corrupted struct pipe buffer, and copy fail corrupted the AFLG output buffer. Dirty frag corrupts the frag slot of the struct SK buff. Totally be like a hacker frog. I mean, I guess you could say you could hop between different subjects, maybe. So the full disclosure document, including the proof of concept, lives at Vaybell Dirty Frag repository. So if you're interested in learning more about the exploit and taking a look at the GitHub repository detailing the exploit, you want to take a look over here. So the combined impact is severe. The chained exploit was tested successfully on Ubuntu 24.04.4, Red Hat Enterprise Linux 10.1, and Alma Linux 10, OpenSUS, OpenSUSE Tumbleweed, CentOS Stream 10, and Fedora 44. The Xfirm ESP variant was introduced by commit, this one over here, on the 17th of January 2017. Okay, so this bug was undiscovered for 10 years. Well, no, not 10 years, 9 years, giving a 9 years of effective lifetime. The RxRPC variant was introduced by this commit in June of 2023. So increasingly, we're finding that AI-assisted, what is it called? AI-assisted fuzzing is helping identify these vulnerabilities from way back when. A short comparison against the two previous room subjects. Okay, so let's take a look over here. So property, kernel structure abused. In dirty pipe, it's struct pipe buffer. In copy fail, it's AFALG output buffer. And in dirty frag, it's struct SK buff fragment. Primitive size here in dirty pipe is arbitrary. In copy fail, it's 4-byte controlled. And in dirty frag, it's 4 or 8-byte controlled. Okay, SysOS says there are also the same kind, just different paths. Something AI is currently suited to help locate. Yeah. So race condition required in dirty pipe, yes, but in the other ones, no. On disk file changed. In all three of these, the file that is being abused does not get written to. File integrity bypass. In all three cases, the integrity is bypassed. Affects all major distros. So in all three cases, all the major distributions are affected. And in this room, our learning objectives are: explain the shared zero-copy splice pattern that links dirty pipe, copy fail, and dirty frag. SysOS says there's also fragnesia, which does like 1 byte or 1 bit at a time. So it's is this the same family of exploits or the same class? We're going to describe the xfirm ESP variant and how attacker-controlled sequence high lands into the page cache. We're going to describe the RX RPC variant and why brute forcing in user space is required. We're going to explain why two variants are chained and how the chain bypasses distribution-specific defenses. And we're going to apply the published mod probe mitigation on a vulnerable host. Claims to be the predecessor of dirty frag. The predecessor. Okay, so the prerequisites of this room. This room assumes comfort with Linux command line operations and working understanding of local privilege escalation as covered in Linux fundamentals. Okay, so connecting to the machine, we've just done this, so we're just going to click check at the bottom of task number 1. Oh, the successor of dirty frag. So it's a later one. Fragnesia is supposed to be the later version of dirty frag. Okay, so we'll move down to task number 2. So dirty frag, copy fail, and dirty pipe are all instances of the same class of bug. Understanding that class makes both component variants of dirty frag straightforward to follow and explains why the chain works the way it does. No worries, no worries. Okay, so struct sk buff in the frag slot. A socket buffer, struct sk buff, usually shortened to skb, is the kernel data structure that represents a network packet as it passes through the stack. Socket buffer, so an skb has a linear data area plus an array of page references called fragments or frags, plus an optional list of further socket buffers, frag list. The combination lets the kernel represent a single logical packet as a chain of memory regions without copying any of them into a single contiguous buffer. The fragment slots are the relevant detail for dirty frag. Each fragment is a reference to a memory page along with an offset in the length. When a fragment is added to an skb, the page is not copied. The skb simply records that this region of memory belongs to it for the duration of the packet's life. The message splice pages path. Splice is a Linux system call that moves data between file descriptors by transferring page references rather than copying bytes. When a process splices from a file into a socket, the kernel does not allocate a new buffer and copies the file's contents into it. The kernel attaches a reference to the file's page cache page cache page directly to the outgoing socket buffer's fragment list. The flag that signals the behavior is message splice pages set automatically by splice to socket. The performance benefit is significant. The expensive bit of network I/O on a busy server is the memory copy from user buffer to kernel buffer, and zero copy paths skip it entirely. The trade-off, however, is that the page reference now sits in a socket buffer whose contents the kernel may want to mutate. If the kernel performs an in-place operation on that fragment, it ends up writing into the page cache of the file the sending process only has read access to. So this is socket buffer FL, shared frag, and why it matters. The TCP stack is aware of this risk. After socket buffer splice from iteration plants a page cache into the TCP socket buffer, the stack sets the socket buffer flag shared flag on the socket buffer flag shared flag on the SKB. Any later code path that wants to modify the SKB's contents checks this flag and copies the data into a private buffer first using socket buffer cow data before performing any mutation. This protects the page cache from corruption. The IPv4 and IPv6 datagram append paths, which UDP relies on, did not. The IPv4 and IPv6 datagram append paths did not set this flag. That oversight is the entire root cause of the xfirm ESP variant of Dirty Frag. UDP socket buffer constructed via splice carrier attack pinned page cache pages with no shared frag marking, looking to the rest of the kernel like ordinary uncloned nonlinear SKBs. The patch for this CVE makes the IPv4 and IPv6 datagram paths. Forgetting a single bit causes all this memory. Oh, okay. Causes all this misery, rather. The patch for this makes the IPv4 and IPv6 datagram paths set by socket buffer flag shared frag to match TCP and adjust the ESP input path to honor the flag. Once the flag is set up, ESP input is forced through socket buffer cow data, and the in-place crypto can no longer reach the attacker's page. In-place crypto, the common sink. What both Dirty Frag variants share is the moment the kernel performs an in-place cryptographic operation on top of an attacker-pinned page. Whether the operation is an AEAD decryption, single block decrypt, or scratch byte rearrangement. The side effect, Mitrok, thank you very much for subscribing on YouTube. The side effect is the same. Bytes are written into the page cache of the file that the attacker only had read access to. So the pattern in pseudocode is 1. The attacker reads the target file, for example user bin su, into the page cache. 2. The attacker constructs a packet via splice so that the file's page is in frag 0. The file's page is in frag 0. Okay. 3. Kernel's network stack delivers the packet to a verify or decrypt path. 4. That path does in-place crypto on source equals destination, where both points at the page. 5. The crypto operation's side effect modifies the page cache. 6. Subsequent reads of the file return the modified bytes. So, the on-disk file is never touched. File integrity monitoring tools that hash the file from disk continue to report the file is clean. Every process that subsequently reads the file, including the kernel loading it for exec VE, gets the corrupted in-memory copy. Okay, so let's go ahead and take a look at this illustration. So the dirty frag primitive. Splice plants a page cache reference into an socket buffer frag, then in place crypto writes it back into the page. What do we got? Linux kernel shared page cache, so the page cache is over here. The unprivileged user, we assume that this is some sort of hacker person, has read-only file descriptor to user bin su. Okay, so Splice plants the page reference, not a copy, just a pointer, into this fragment here. And then the in-place crypto modifies the information here. So the on-disk file is never written. The page cache is the only thing that gets corrupted and only inside the memory. Mark is complete. So it looks like we've got two versions of this exploit that we're going to be messing around with. Okay, so task 3 is the xfirm ESP page cache write, which is the CVE here. The first half of the dirty frag is a 4-byte controlled write into the page cache delivered through the kernel's IPsec ESP input path. The bug has been present since January 2017, giving it the same 9-year lifespan as copy-fail. Where the bug lives. The relevant function is ESP input in net IPv4 ESP4.c and its IPv6 sibling in net IPv6 ESP6.c. Before the patch, the input path took a fast path that skipped socket buffer cow data, where the SKB was uncloned and had no frag list. Even if the SKB carried fragments planted via splice, the decision branch looked like this. Okay, if not SKB cloned SKB, and if not SKB is nonlinear, nfrags equals 1, and then go to skip cow. Else if SKB has frag list, then nfrags equals SKB shinfo for the SKB, nfrags incremented, go to skip cow. Okay, so I don't really understand what's going on in the code here, but we'll just press the I believe button and move on. So a non-linear SKB with no frag list, made out of the attacker pinned page cache pages, jumps straight to skip cow from there. Crypto auth encode ESN decrypt ran in-place AEA decryption with source and destination pointing at the same scatter-gather list, both rooted in the attacker's page. The 4-byte store. Inside crypto authenticate encryption ESN decrypt, before the actual decryption, the algorithm rearranges the sequence number bytes. As part of the rearrangement, it performs a 4-byte write at associated length and crypt length within the DST scatter-gather list. Okay, so scatter, walk, map, and copy, temp plus L, destination, associated length plus crypt length for 1. So the value being written in this high order 32 bits of sequence number, sequence high, that value is set by the user when registering the IPsec security association by the xfirm replay ESN val netlink attribute. The user fully controls it. Okay, the position of the write is also controllable by tuning the payload length and the splice offset so that the attacker's page sits exactly at associated length plus crypt length, position at the DST destination SGL. The 4 bytes land at any chosen offset within the page's cache. The HMAC verification afterwards fails. The attacker has no idea what the legitimate authentication key is, and supplies a random one. An bad message is returned to user space. However, the 4-byte write has already completed before the verification step. The error has no effect on the corruption. Privilege requirement. So, ESP input only fires for traffic destined for a registry IP security association, and registering an SA requires cap net admin. The exploit obtains that capability by entering a new user namespace via unshare clone new user, clone new net. Inside the namespace, the process maps itself to root UID map 0, real UID 1, and gains cap net admin for the namespace's network operations. This is where Ubuntu's app armor policy becomes relevant. Ubuntu often blocks unprivileged user namespace creation through a system-wide app armor profile. On hosts where the policy is active, unshare clone new user returns eperm, and the xfirm ESP variant cannot be triggered at all. That blind spot is what the RX RPC variant in task 4 exists to cover. How the trigger reaches ESP input. A direct socket AF inet socket raw IP protocol ESP to inject ESP traffic would be visible to any kernel filter watching for raw sockets. The exploit instead routes through the UDP encapsulation path. A UDP receiver socket is bound to 127.0.0.1 4500 and is configured with set socket option, or at least I think it's option, sol UDP, UDP encapsulation, I'm not too sure what this thing is, ESP in UDP. A sender UDP socket connects to the same port. A pipe is filled with the forged ESP wire header, 8-byte header plus 16-byte IV via VM splice, then 16 bytes of user bin SU's page cache via splice. A final splice from the pipe to the sender socket sends the packet. Once the ESP in UDP marked socket receives a packet, UDP queue receive one socket buffer routes it through xform 4 UDP encapsulation receive and into xform input, which delivers it to ESP input. The flow runs entirely over loopback. The packet's SKB, or socket buffer, arrives at ESP input looking like this. So SKB, header linear, ESP, I think IV stands for like induction vector, and this is 24 bytes. Frag's element 0 is page equals something something, and this is the page cache of user bin SU. So user bin SU is the binary that we're targeting with this particular exploit. So the fast path triggers the in-place decryption runs, and the 4-byte write lands at the offset I times 4 of the page. By cycling I from 0 to 47, the exploit assembles a 192-byte static ELF over the first 192 bytes of the cached user bin SU binary. Then the static ELF executes set GID 0, set UID 0, and exec bin sh at its entry point. So this is our good old root shell that we're creating over here. So the setUID bit on user bin SU is intact throughout. The kernel still grants effective UID 0 when the binary is executed. The shellcode runs as root. Okay, so we're still not running this. Let's move on to the other version of the exploit. So the second half of Dirty Frag is structurally similar to the first, but lives in a different subsystem and has different operational properties. It is a variant that runs on hosts where the xfirm ESP variant is blocked. Where the bug lives. The relevant function is rxk ad verify packet 1 if the rxrpc kernel module rxrpc.ko in the RPC kernel module. Okay, so rxrpc is the kernel-side implementation of the RPC protocol used by the Andrew file system. The verify function performs an in-place single block decrypt on the first 8 bytes of the RxRPC payload. Okay, we'll skip the code block. Socket buffer to SGVEC and translates the socket buffer's frag directly into the scatter gather list. If the frag was planted by a splice, the list now points at the attacker's page cache page. The set crypt calls with SG. SG makes the operation in place, and the decryption runs and writes 8 bytes back into the same page. The 8-byte store. The cipher in use is PCBC fcrypt. With the IV set to 0 for a single block, PCBC reduces to a plain fcrypt decrypt CK, and fcrypt is an Andrew file system cipher with a 56-bit key and an 8-byte block. This is where the RxRPC variant differs sharply from the XRFM ESP variant. With XFirm ESP, the 4 bytes written are sequence high, a value that the attacker hands to the kernel directly. With RxRPC, the 8 bytes written are fcrypt decrypt CK, where the C is the actual ciphertext bytes that already exists at the file offset, and K is the session key that the attacker registers in user space. The attacker then can therefore choose K, but cannot directly choose what gets written. To plant the desired 8-byte plaintext, the attacker has to brute force K in user space until fcrypt decrypt CK returns the desired pattern. The cost grows exponentially with the number of constrained plaintext bytes. Constraining all 8 bytes is infeasible, around 2 to the 56 power keys, but constraining only 2 or 3 bytes is fast. Privilege requirement. The session key is registered via add key RxRPC, description, payload, key spec, process, keyring. Registering an RxRPC key requires no special capabilities. The trigger uses a UDP socket pair and an AF RxRPC socket, both of which are accessible to unprivileged users. No namespace creation is required. The constraint that affects this variant is module availability. The RxRPC variant only works if the rxrpc.ko module is loaded. The Weibel write-up specifically calls out Red Hat Enterprise Linux 10.1 default build is not shipping rxrpc.ko, and notes that the module is absent from most distributions in general. On Ubuntu, however, the module is loaded by default, which is precisely where the namespace blocking AppArmor policy makes the XFirm ESP variant unreliable. Each variant covers the other's blind spot. Choosing etc. password instead of user bin SU. The XM's ESP variant overwrites a 192-byte ELF over user bin SU in 48 separate 4-byte writes. The RxRPC variant cannot do this. Each 8-byte write requires its own user space brute force, and even with fcrypt running at around 18 million keys per second, writing 192 bytes on a fully constrained shellcode would take longer than several lifetimes. This variant targets etc. password instead. The first line of etc. password reads root x0, so root bin bash. The exploit overwrites characters 4 through 15 with the pattern ::0:0 many G's, using 3 overlapping 8-byte writes at offsets 4, 6, and 8. Last write wins, resolves the overlap. The result is root no password. Root no password. Huh. So they overwrite the etc password file and they set the password did nothing. Note that the password field is now empty. PAM's pamunix.so nulllock accepts an empty password and returns PAM_access without prompting. A subsequent SU runs without any authentication change, drops the UID to 0, and execs bin bash. Only 12 bytes of plaintext need to be controlled, of which 5 of them need to carry the very weak constraint of anything other than : new line or null. The brute force completes in roughly 5 milliseconds for the first 2 writes, and around 1 second for the third. Okay, and then we get to run the exploit. Okay. Why chaining is necessary? Each variant has an environmental constraint that prevents it from working on certain distributions. The Xfirm ESP variant requires user namespace creation, and Ubuntu often blocks that via AppArmor. The RxRPC variant requires rxrpc.ko, and most enterprise distributions do not ship it. Neither variant alone covers Ubuntu on Red Hat Enterprise Linux simultaneously. Chaining the two variants makes their blind spots cancel out. The exploit attempts the Xfirm ESP variant first. If unshare clone new user returns eperm, or if SA registration fails, the exploit falls back to the RxRPC variant. Between the two, every tested distribution has at least one path that works. So the fallback logic in pseudocode. 1. Fork a child process. 2. In the child, attempt the Xfirm ESP variant. Unshare usernet. Register Xfirm SA. Okay, we've got an ad running on Twitch right now. When ads run on Twitch, we take a break. And I've been doing a lot of reading. But in the meantime, check out these birds. Okay. Check out these birds. We'll be back in about 60 seconds. I just need to take a water break. My poor voice. All right. It has a lot of text. So this bird is is kind of funny because his throat pouch is stuffed with peanuts, and he can't actually close his beak to get more peanuts. So it's kind of funny. Anyways, we'll go back. Okay, check whether the first byte of the shellcode landed at the entry offset. If yes, parent fork pty and exec user bin su to get a root shell. If that didn't work, then fall back to the RxRPC variant, brute force k 3 splice triggers to modify the etc password file. Okay, password emptied, parent fork sudo terminal, pty is and then exec ve user bin su, pam nulllock into the root shell. Okay, so let's see. Let's take a look at the image over here. So why dirty frag chains two variants? Each variant is blocked on different distributions. Together they cover every major Linux distribution. So they try the Xfirm ESP variant first, and if it doesn't work, then they try the RxRPC variant over here. This leads to root on every major distribution of Linux, because the two variants cover each other's blind spots. Okay, so connecting to the lab machine. So we're already connected to the lab machine. Let's see. Confirm your context. Confirm the current user has no elevated privileges. So we can drag in our attacker, well, our victim machine over here. Okay, and we will confirm our context. So the Karen user over here that we're running as doesn't have any special permissions. So this is a starting context that the exploit requires. No special groups, no pseudo entitlements. Step 2, inspect the proof of concept. The published Dirty Frag POC is hosted at the GitHub repository over here. I'll leave you a link in case you want to take a look. A pre-built copy lives at home Karen Dirty Frag exp.c on the lab machine. Take a quick look at the structure. Okay, so we need to move into the Dirty Frag directory, and we've got our C code over here for exploit.c. Oh, we were supposed to do head 50. Okay, so it includes a lot. Well, the one thing that I noticed right here is that it includes a lot of libraries. Okay, so the exploit is in a single C file. It has no build dependencies. Beyond a working C toolchain and libutil used for forkpty. It is compiled with the same one-line command shown in the upstream README. Okay. Build and run the exploit. Build the binary. Wait, is it not pre-built here? It looks like it's free. It is pre-built, but we can do it anyways with the GCC. So we'll compile the binary from the C code, and we're gonna output. We're going to call this exp1, just to make it... Just so that when we try the initial one that's already in here, we have it available. So exp1, this is our exploit file that we compiled. Then we run it. The exploit prints progress as it works through the variant logic on Ubuntu 24.4. With AppHeimer's standard policy, the xfirm variant fails on the unshare step, and the RxRPC fallback kicks in. The brute force phase prints the keys as they're discovered, and then the 3 splice triggers fire in sequence. After the modification is complete, the exploit calls forkpty and then runs su-, dropping into a root shell. Okay, so let's try this out. So it tells us that we should be seeing some... We should be seeing output here. Okay, it didn't show us any output. That's funny. I mean, it might be because of the way the terminal is configured here. But I mean, we are root now, so we can cat our flag.txt file. Ooh, gotta spell that correctly. Okay. Try sunid. I mean, ID, we are root. And I guess we got our flag, so we could use our good old flag emote over here. Just like this. Okay, so let me copy the flag and I'll keep it in a safe place. Okay, read the flag. Cat root flag.txt. Verify the on-disk files. While the root shell is still active, check whether either of the files modified in the memory was actually written to the disk. So let's take a look at etc password. So because this is an Ubuntu system, Was it uname-a? Yeah. Linux Dirty Frag, this is a version of Ubuntu, and because it's a version of Ubuntu, then we should have had to modify the etc password file. Okay, so if we look at etc password, we head that. Huh, it was modified. So normally, for each one of these users, there should be an X. So it looks like it should be modified while we're in our root shell, and after we exit from our root shell, then it should return back to normal. Okay, so both hashes match the values of freshly installed system. The page cache was modified, but the on-disk content was never written. Okay. The exploit cleans itself up with POSIX F advise, POSIX F ADV don't need on the affected pages. After the corrupted process exits, the kernel evicts those pages from the cache, and the next read of etc password or user bin su reloads the clean copy from disk. Okay, so let's exit. So we exit, we're back to our Karen user. So if we take a look at etc password now, it's still modified. That's not how it's supposed to go. The exploitation window is short. Once the cleanup runs, no on-disk forensics evidence remains, and the page cache no longer reflects the attack. We should... Wait. If this is the actual etc password file, then we should be able to... You need to flush the page cache. How do we manually flush the page cache, though? Because we can become root without providing a password, because the etc password file has been overwritten still. Echo T1 proc VM drop caches. Well, I mean, we can try. We probably need to do this as... Wait, do we need to do this as an elevated user? We need to do it as root. Okay, so I mean, we can become root. This is weird. Hold on. Okay, so this is what we want to run. It doesn't let me paste. That's okay, we can just write it out. No such file and directory. Did I misspell that? Proc sys VM drop caches. Okay, so exit the root shell. What is the content of flag.txt? I might as well copy this. Did I make a typo? Oh, I did. Yeah, okay. Let's try it again. Okay, so root... Yeah, okay, this reverted. This reverted it back to its original form. So root should have a password now, so if I exit out of here, and then I try to become root again, it'll ask me for the password, and I don't have it, so I can't become the root user again. Okay, good. Okay, so detection and mitigation. So we've got about 12 minutes to wrap up the room. Their dirty flag exploit leaves no on-disk forensics trace, just like copy fail and dirty pipe. What it does leave is a distinct sequence of system calls that no legitimate application produces. Detection works by monitoring for that sequence in real time. Mitigation works by removing the kernel modules that deliver each variant. So detection. Xfirm ESP variant. The Xfirm VSP variant produces an unusual chain of system calls in a single process. So it runs unshare, clone new user, clone new net, followed by writes into proc self UID map, a burst of around 48 Xform message new SA net linked messages, each with a each registering a different SPI. A socket IFINet sock dgram with set sock options sol UDP, UDP encap, UDP encap, ESP in UDP set to value 1, repeated VM splice and splice calls feeding /user bin su or another set UID binary into the encap socket, and an eventual execve user bin su something something. A Falco rule that fires on the splice from set UID binary to encap socket pattern catches this variant before the page cache corruption is complete. Falco does not expose a direct user namespace flag, so the rule below leans on the splice target plus the binary being spliced as the high fidelity signal. So we've got, I suppose the Falco is some sort of EDR, endpoint response tool. I'm not super familiar with that. And the RxRPC variant. So this variant has a different signature. It does not use namespaces, but it does the following. So let's see. Socket AF RxRPC, sock dgram, demand value 33. 3 or more add key RxRPC calls in quick succession with different descriptions. Repeated VM splice and splice calls feeding etc. password into a UDP socket. An eventual exec VE user bin su, followed immediately by a child process running bin bash as UID 0. SysOS says it's a eBPF endpoint protection tool as far as my research showed. Okay. So the socket RxRPC call by itself is a high fidelity signal. RxRPC is a narrowly used protocol, primarily deployed for AFS clients. Most production hosts never legitimately call this socket family. A SIM rule that alerts on any process opening an AF RxRPC socket outside a known AFS client process lists as a strong starting point. Okay. Key syscalls to monitor. So socket AF RxRPC, socket AFINet sock dgram with UDP encap ESP and UDP, unshare clone new user, add key RxRPC, splice from set UID binary or etc. password to socket FD. We got MITRE attack mapping over here. And we've got mitigation. Just a second, everybody. I want to start up my new music. Back in a second. Okay, so the mainline patch for CVE 2026, this thing, is this commit right here. It was merged into the NetDev tree on 7th of May 2026 and accepted into Linus's mainline tree on the 8th of May 2026, the same day the NVD record was published. So the patch sets SKBFL shared frag on spliced page fragments in the IPv4 and IPv6 datagram append paths and updates ESP input to honor the flag. Once the flag is set, attacker pinned pages are routed through SKB cow data before any in-place crypto runs. So this CVE here has no patch in any tree at the time of disclosure. The author submitted a patch to NetDev but has not been merged or backported. Until a patch kernel is available from your distribution, the published interim mitigation removes both attack surfaces by disabling the kernel modules that contain them. Step 1. Apply the module deny list. So what's going on here? Okay, so I'm just going to copy these commands. And before we run them, let's take a look at what they're... Well, let's try to decipher what they're actually doing. Okay, so printf install esp4 bin false, install esp6 bin false, install rxrpc bin false, into etc modprobe.d dirty frag configuration. Okay, so this is something specific for a configuration file. Okay, so let's try running this first. What is the password for Karen? Do we need to become the root user to do this? Oh, okay. Hold on. So to do this, you need to have root privileges. Hold on. I think there's a password for this user at the top of the. Well, not the top, but in one of let's see. Chaining and running the exploit is over here. The password is dirtyfrag 2026. Okay. Sorry, try again. What? Dirtyfrag 2026. Karen is not in the sudoers file. Oh, okay. So we actually need to become the root user to implement the patch. So I guess we need to run the exploitation script again. That's funny. Okay, well, run the thing, and then we do the second thing. Okay, and then run this command. Maybe change the sudoers file to get persistence. I mean, I don't think we need to get persistence because we're pretty close to finishing the room. But yeah, I mean, if you wanted to get persistence, you could do that. Okay, so run this command and then run the third command, which is drop caches, right? Okay. So this is similar to what SysOS Master was talking about. So echo 3 into procsys VM drop caches. So this changes the page file. Okay, the first command writes a modprobe configuration file that intercepts load of ESP4, ESP6, and RxRPC, redirecting them into bin false, so the module never loads. The second unloads any currently loaded copies. The third drops the page cache, evicting any pages that may have been corrupted. Huh. So if it resets the page cache, then etc password should be modified, right? Well, should be its original form right now. But it's not, because we're still inside of this thing. So we'll exit from here, then we'll check again. It's still not, it's still modified. Okay, verify that the block is active. Both commands should now fail. If either succeeds, check the configuration file is written correctly. Confirm that the POC fails. So we'll try rerunning the exploit, and we'll confirm that it still succeeds. Okay, well, I mean, that's fine. We just did it wrong. Okay, patch status at disclosure. The disclosure time runs. The disclosure timeline runs roughly as follows. The Xfirm ESP patch was submitted to NetDev on the 30th of April 2026 and merged into the NetDev tree on 7th of May 2026, followed by mainline acceptance on the 8th of May 2026. The RX RPC patch was submitted on 29th of April 2026, but has not been merged. The embargo with the Linux distro's mailing list was broken by an unrelated third-party publishing the exploit on 7th of May 2026, prompting the author to release the full Dirty Frag document. NVD published this CVE number over here, record on the 8th of May 2026. Did we, or did THM? I'm not too sure. Okay, so, well, we finished the room. So the conclusion is, Dirty Frag is the third vulnerability in a now recognizable bug class. Dirty Pipe abused the pipe subsystem. Copyfail abused AFALG, and Dirty Frag abused two unrelated network paths. All to achieve the same end. An unprivileged user writes into the page cache of a file they only have read access to. The on-disk content is never touched. File integrity monitoring is silent, and the corruption persists in memory until the kernel evicts the affected page. The class is durable because the underlying pattern in-place crypto on a non-private socket fragment reoccurs across many subsystems. Each instance has been independently introduced, often by performance-motivated optimizations that did not consider how splice could plant attacker-pinned pages into a downstream socket. Okay, socket buffer. So Xfirm ESP was introduced in 2017, RxRPC in 2023, and the copyfail equivalent in 2017. Reviewing in-place in-place crypto sites for the same pattern is an active area of research. For defenders, the key takeaways are unchanged from copyfail. File system integrity monitoring is not sufficient on its own. Detection requires syscall level visibility, ideally in real time, with rules tuned for the specific socket types and splice targets each variant relies on. Mitigation requires a patched kernel. Module deny lists are an effective interim, but break legitimate functionality where those modules are needed. The patch for CVE 2026, this thing, is upstream. The patch for this one is not. Until both are merged and backported, the module deny list is the recommended interim control on hosts that do not depend on IPsec or RxRPC. Okay, and then we finish the room. Okay, that's done. Alright, so I think we might spend a little bit more time doing some extra CTF challenges. Just in time finish, I guess, kind of, yeah. Anyways, we'll try doing some extra challenges over at our current favorite website for doing CTF challenges, and that's HackerPoll. So HackerPoll has a bunch of challenges from the French cybersecurity challenge CTF that occurs every year, and if you want to give it a try yourself, you can do so entirely for free. They've got an English version of the page. It's Brody. Hello, nice to see you here. The box, exited itself. Okay. Truther says, did PicoCTF get renamed? Yeah, PicoCTF is not PicoCTF anymore. PicoCTF is now Scilab, so Scilab Academy. So if you have got an account over at PicoCTF, you can use the same login information. But in the meantime, let's take a look at HackerPoll. I think we could take a look at the HackerPoll. The other thing we could do is we could finish off the CTF challenge that we were doing earlier. So the CTF challenge we were doing earlier was this one doing forensics on database. So database forensics. I think I'd like to do the database forensic stuff now while it's still fresh in my memory. If you want to give it a try yourself, you can use this link over here. So we were, whoops, we're looking through a SQLite database. We're taking a look at the transactions. I think what we needed to do was we needed to do like a join. But I kind of forget how to do joins instead of SQL. So let me see if I can adjust my overlays. So we're currently doing topic number 2. So what I want to do is I want to refresh myself on how to do joins inside of SQL. SQL, how to use joins. And Lucky Ducky has subscribed on YouTube. Thank you very much. Much appreciated. Okay, in SQL, a join is used to combine rows from 2 or more tables based on the related column between them. This allows you to treat separate tables as one unified data set for your query. So the most common way to join tables using the join keyword and the on clause to specify the matching columns. So select table1.column name and then table2.column name from table join on this thing. Okay, let's take a look. So we got our text editor over here, and let's just take a good close look at this. So select table1.column name, table2.column name. So I guess what we're dealing with is we're looking at the user's user ID, and we're looking at the table 2. The column word we want to look at is the status column from the transactions table. Okay, so select these two things from table 1. So table 1 is users. Join table 2. Table 2 is transactions. On table 1 column name, table 2 column name. So it's going to be user ID for both. And the column names are transactions and users. Because we've been struggling with this thing for a little bit. Let's see what happens if we give this. Okay, so we got completed, failed, and what we need to do further, well, what we need to do now is we need to further refine the results from the database. So I guess we put the where clause before the join. So we'll do from users where status is equal to completed. Okay, they don't want the join there. They probably want the join right here. Okay, so this is... This looks okay. I guess the other thing we need to do is we need to sort these now, right? Where status equals completed, order by user ID. No. Maybe order by users ordered ID. Users.user ID. Okay, so this... This seems to work. And unfortunately, it doesn't look like we're getting any different results. Order by users.user ID. Are we asking the right question? That's a good question. So we're ordering... Oh, maybe we need to order them by something else. You know what? We need to order them by email? Maybe we need to order them by email? We could cheat. We could probably cheat. If we wanted to cheat, what we would do is we would just copy everything and then use like some Linux commands like unique or sort. Unique and sort is what we would do. So we might cheat a bit, and then afterwards we'll try to figure out how to use the SQL commands. So here, what we do is we would cat out output.txt and then pipe it into sort unique C. And then sort again. This doesn't help us at all. This gives us the same kind of result. Wolf201, thank you very much for subscribing with Tier 1 on Twitch. Thank you very much. Let's give you a fun video redeem for you. How about some Hack the Planet? Just for you.
Hack the planet! Hack the planet!
Okay, because we see a lot of users had 4 completed transactions. So there must be something I'm doing wrong. Okay, so let's check the schema for transactions. So transactions as TXID, so transaction ID, user ID, amount, date, and status. What other tables exist? We have logins, message, metadata, transactions, and users. So let's take a look at the logins. So schema logins. So we've got login ID, user ID, timestamp, and their IP address. We also have messages. But I'm pretty sure that the thing we need to pay attention to is the transactions. Select star from transactions. And so how many of these transactions are there total? So there's 500 total. If we're just looking for the completed transactions, this is 438. You know what? You know, SysOS, maybe you're right. Maybe we need to order them by email. Maybe we need to order them by email. So in that case, we do need to do a join. So we would select not users.id transactions.status, but users.email. Transaction status from users, join transactions on users.users.id, transactions user as ID, where status equals completed, and we'll order them by users.email. Okay. And just for fun, we'll try feeding this into Linux. Sorry, into our terminal. We might get a different result if we do it by email. Okay, we'll go back in. We will then we'll do our same thing. This is closer. We might need to merge the uppercase and the lowercase content, because we got uppercase user and then lowercase user. So maybe we need to do like a transformation. So transform uppercase user into lowercase user before we do anything else. So cat this out and then transform. Uppercase user into lowercase user. And then do the same thing. We sort and then we get the unique count and then sort it again. Same thing, huh? We've got two users who are tied. So we got user 14 and user 44, but they're only looking for one. I'm pretty sure they're only looking for one user. What is the ID of the user who has generated the most successful transactions? And what happens if we go back here and we select users.email, transactions.status, and we also get transactions.user ID. Okay, we need to make sure that these users match. But maybe some of these user IDs are using different email addresses. Most successful, could that be metaphor, as in the amount transferred? Hold on. Generated the most successful transactions. Generated the most successful transactions. So are we talking about an amount? If we're talking about an amount, then it's a totally different thing. It's probably a lot easier if we're talking about the amount instead of the number of transactions. So, okay, let's try it your way, SysOS. So let's talk about the amount of money. So the amount of money, first of all, we can get the you can select the sum from transactions where status equals completed, like this. Go back. And then we can kind of combine it. So we're not selecting sum. I guess we are kind of selecting sum. Yeah, the current path isn't giving us what we want. So replace amount and then euros. Let's see, from transactions where status equals completed. So we need to combine these two queries somehow. So let me copy this. So we're selecting here, select users, user ID, transactions.status from users. In this case, we're looking for not transactions.status, instead we're looking for the amount. Transactions.amount, but we also need to do the sum replace here. Sum replace transactions.amount, euro, replace it with empty string, and then do the thing. Okay, so we're still looking for user IDs, I guess. From users, join transactions on users user ID, transactions.user ID. Something tells me that this isn't going to work. Okay, so let's try presenting this to our good friend the AI. So SQL, how to select how to group all, add all, man, this seems kind of complex. Okay, let's go to our good friend Perplexity over here. Okay, we'll make a new little conversation, and let's just tell it exactly what's going on. Okay, so we have an SQL database where we want to sum up all transactions the transactions made by different users in the system identified by the user ID column. Sum up all the transactions identified by the amount column made by different users in the system identified by the user ID column. So for example, user ID 50 may have 3 transactions in the amount of 100, 300, and 500. We want to get the sum of all the amounts by the same users with the same ID number. Okay, so can we get an answer? Use sum with group by user ID to total each user's transactions. For example, the query would be select user ID sum amount as total amount from transactions group by user ID. Group by user ID. This returns one row per user ID with all their amount values totaled together. For example, user 50, okay, we'll get 900 as the amount. If you want only one specific user, add a where clause. Okay, well, I mean, we'll try this. We also need to use the replace function as well, because otherwise it's not going to work. So select user ID sum replace. Hold on. Sum replace amount and then the euro symbol over here as total amount from transactions grouped by user ID. Okay, so we'll just modify this over here. Oh, it looks like we don't have the right number of parentheses. Okay, so we'll try this. Okay, so I think I think it's working. We just need to group this into descending order, right? So order by amount. Order by total amount. Okay, so we have one distinct winner in this case. So the one distinct winner is user number 41. Let's try submitting 41 as the answer. Of course, if it was 42, it would make more sense, of course. So 41. Okay, I'm not logged in. Oh, you know what else? You know what else I forgot? We needed to do the filter where it has to be successful. Okay, so select user ID sum as total amount from transactions. We also need to do where status is equal to completed. Okay, it's the same. Well, I mean, it's the same either way. Where group? Is it where group? But anyways, we'll try submitting the number 41. So HFE grind, coin, 40%, huh? Access granted. Okay, so that was the correct answer. Oh, that took a long time. Okay. So we can continue with our write-up. So question 2, question 3, what is the ID of the user who has generated the most successful transactions? The most successful transactions. Okay, let's continue editing this file. So for this question, we need to pay attention to the user ID status columns in the transaction tables. We also need to pay attention to the amount columns. Okay, so for this question, we need to pay attention to the user ID, amount, and status columns in the transactions table. We need to combine, well, what the question is actually looking for is the user with the most, with the largest value. Overgrown Carrot has rated me with a party of 5. Thank you very much, Overgrown Carrot. And what was Overgrown Carrot getting up to on his channel? Let us know. Welcome, Raiders. And everybody, if you want to hang out with more InfoSec people, Overgrown Carrot also does streaming. Let's give him a shout out. Shout out, Overgrown Carrot. There we go. So everybody, let me know what Overgrown Carrot was doing on his stream. Thank you very much. And welcome in, Raiders. Okay, so what we're currently doing, my name is the Shy Hat. I do cybersecurity content on YouTube and Twitch, and we're currently doing some database forensics. So we're doing a challenge from hackmyvm.eu. It's a very fun platform. And we're doing this challenge here where we have to investigate a bunch of a database full of tables and answer a bunch of questions. So it's basically testing our SQL skills. I need more caffeine. Hello, nice to see you here. AD stuff. Were you doing the Hack Smarter website, or were you using another platform? Let me know. Okay, so I'm just doing a little write-up here and trying to solve the CTF at the same time. So the question is actually looking for is the user with the most transaction amounts. Okay, so this SQL query will let us know. Okay, so the SQL query that we used is over here. Yeah, okay. So most people who deal with SQL in a security context mostly know about doing SQL injection, and using SQL for its intended purpose is a different thing. Okay, I Need More Caffeine says, yeah, it was Hack Smarter. Wow, there is like no delay on your stream as a quick response. Oh, really? Because I've been having some connection issues. It's more fun. I mean, knowing how to use a system in its intended way is also pretty fun, and SQL is a pretty robust language for making database queries. So it's not bad. It is enjoyable. Okay, so the next question is question number 4. So let's go ahead and get that question. Okay, was it not Turing complete? Turing complete, you mean SQL, or are we talking about something else? Hack Smarter? Which Hack Smarter module were we talking about today? Was it... they've got like 2 of them out now. I think one of them's called Shadowgate, and the other one was called like Martini AD. SQL, is it Turing complete? I'm not too sure. Okay, so the next question is, we need to see if our friend left a trace. Tell us which user ID has the most IPs. Which user ID has the most IPs in a single day? The most IPs in a single day. Okay, so let's copy this question and then copy it to our write-up, and then we'll get started trying to figure out what we need to do here. Okay. All right, let's go back in. So we've got our tables. We've got logins, message. So I think we need to deal with logins here, because the question is asking us which user ID has the most IPs in a single day. It probably has to do with logins. I Need More Caffeine says, I think it was Martini AD. It was my first intro to Hack Smarter. It's mostly been doing Hack the Box myself. Yeah, I mean, Hack Smarter, its library of modules has been growing slowly but steadily, like maybe 1 new module or like 2 new modules per week, and he's very quickly growing to have like I mean, you know, the more modules he has, the more incentive people have to sign up to his paid subscription, because they get more bang for their buck. Okay, so we need to pay attention to the logins, to the logins table, and I think maybe we need to also pay attention to the users table. We might have to do a join here. So let's see, .schema logins. We got login ID, user ID. Okay, so I don't think we need to do a join. We just need to get the unique user IDs, and we need to figure out which user has the most IP addresses. Aman Bench says, I was asleep. Did you solve the max successful translation user ID problem? If yes, how? So we figured out that the question wasn't actually asking us for the number of transactions. It was asking us for the amount, the user with the biggest amount of transactions, so the biggest value. So we created a little query over here to get the amounts. Nerdy Science says, sure, I'm late to the party, but I came across a fun demo that teaches SQL called Database Detective. I'm not associated with it, just thought it was fun. Database Detective, huh? Let me do a quick search for that. Oh, really? Okay, okay. So this is an actual game. I thought you were talking more about something like SQL Murder Mystery, which is also something that I've been using to teach people about using the SQL system. I Need More Caffeine says I would recommend SQL Bolt. It was very useful for a beginner. Saved during my database course. Saved me during the database course. New stream warm-up game? I don't know, maybe. I'll take a look at it later. But let's see. I Need More Caffeine said something about SQL Bolt. Oh, okay. So this is like a course. So they've got like a program. So this thing right here. Planned release date July 2026. It's not out yet. That's unfortunate. Okay, let's go back. Okay, so we need to see if our friend left a trace. Tell us which user ID has had the most IPs in a single day. The most IPs in a single day. So if we go back to our table here and we just, let's see, select user ID IP from logins. Okay, so we got our user IDs here, and we need to count the number of logins. SysOS says download Database Detective Minor Crimes Division demo. Oh, the demo's out, but not the full game. Okay. So we got our user IDs and we got our IP addresses. So we got the user IDs. Oh. Why does this go in order? No, it doesn't. Okay, it doesn't go in order. Select the user ID, IP. I mean, what if we just do everything from the logins? So we got them. So we have the ID numbers. So the login ID number. We've got the user ID number. We've got the. Oh, it's from way in the future, 2097. Okay, and then we've got the IP address over here. So user ID IP from logins. We need to order by user ID. So we probably want to do it like group by. So let's see. Oh, we also want to get distinct IPs. So select user ID. Let's see. So this is SQLite. Well, I mean, I think all the systems handle distinct entries the same way. SQL distinct rows. Okay, to retrieve distinct rows, you'd use the select distinct statement. So distinct is a keyword placed immediately after the select keyword. It applies to the entire row, all columns selected, rather than just the column next to it. So select distinct country from customers. So instead we're going to do distinct IP. So if we're highlighting it like this, and we do order by. Okay, so distinct has to go in front, I guess. Select distinct. User ID IP. Okay, so that just eliminates the duplicates. Okay, I think you can solve it by using group by user ID and counting IPs. So where would we stick our group by user ID? So group by. I mean, I don't think this is producing what we want it to be. Yeah, I'm... So we have our user IDs here, and we've got our different IPs. So for example, 146 has you should count the IPs. Count IP. Select distinct user IP, count of IP. Let's not use distinct in this case. So count of IP. Yeah, this isn't quite working. Okay, so let's go back. So we could probably let's do the cheat method. So the cheat method is going into here and then using our Linux, but we'll go back in and figure it out manually afterwards. This is, I mean, I have not had to think this hard about SQL queries in a really long time. Actually, you know what? Let's just ask a little question. So SQL. Select distinct user ID IP. User ID IP, so get rid of all the duplicates. So distinct gets rid of all duplicates when we do our if we order them by user IP, then all the user IPs that are the same, the user IDs that are the same, all come up together. Like this. So what we want to do is we want to get a count of these user IDs. Select distinct user ID IP from logins, order by user ID. I need to, so we've been using this group by keyword as well in SQL. I don't use it very, I don't use it very often, so I want to get a clear understanding of what group by actually means in SQL. Let's take a look at the W3 schools. Oh, wow, this is really bright. Where's our dark mode? Ah, much better. Sorry, everybody. That hurt even my eyes. Okay, so the group by statement is used to group rows that have the same values into summary rows, like find the number of customers in each country. The group by statement is almost always used in conjunction with aggregate functions like count, min, max, min, sum, average to perform calculations in each group. Okay, so select column 1 from table name where condition, group by column 1, column 3. Below is a selection from the customers table in the Northwind sample database. Group by examples. The following SQL returns the number of customers in each country. Select country count of customer ID as number of customers. From customers, group by country. Group by country. Thank you very much for subscribing on YouTube. Strive. Much appreciated. Thank you very much. The following SQL returns the number of customers in each country sorted from high to low. The number of customers in each country sorted from high to low. So this is kind of like what we're looking for. So select, let's copy this. So we'll copy this. Actually, if we try this out ourselves, returns the number of customers in each country sorted from high to low. Okay, so if we run this, then we've got number of records 21. So USA, number of customers, USA, number of customers, France, number of customers. So what we want is our user ID over here and the number of IPs in the other column, right? Okay, so let's copy this and then we can try to adjust this to our circumstances. Okay, so in our case, we're grouping them not by country, but by user ID. And we're going to order them by count. Count customer ID as number of customers. As number of customers. Well, I mean, we're not really returning any column names in this case. So I think we don't need the as in this case. So let's just get rid of this. So we're selecting user ID, count of IP from, so the table in this case is logins. We're going to group it by user ID and order by count of IP descending. Okay, and let's see if this works. It looks like each... Okay, so this is descending. We probably want it to do it ascending. Because it looks like... we've got one user that has 10 IPs. So user number 42 has 10 IPs. So that's the winner right over there. Okay, let's go ahead and submit the answer. So the answer is 42. The answer to life, the universe, and everything else. Is that what it's called? Access granted. Okay, that was the right one.
This one's dedicated to all the hackers.
This one's dedicated to all the hackers, right? Thank you very much for the all the things redeem. I need caffeine. Thank you very much. We got that flag. Yeah, goated song. Yeah, I wish I could play more of it on the stream, but that would get me in trouble with YouTube. Okay, it appears the system left a fragmented message. We'll cover that later. Okay, so let's take a look at our right up over here. Let's see, we need to pay attention to the logins table, and we need to not just the logins table. We need to pay attention to the user ID. And IP columns in the logins table. And we need to group by with a count of the IP column as well, and then we can give our actual command over here. Portbuster, hey, wow, I haven't seen you in my stream for a while. I usually see you in PicoCTF's stream. But welcome to the stream. We're doing some database forensics over at HackMyVM. This has been a pretty fun challenge. I haven't had to think a lot about advanced SQL queries, but apparently we're doing them. Happen to have some time today. Okay. I mean, Portbuster, you're also in... Are you also in, like, the Scandinavian countries? Or are you somewhere else in Europe? Okay, you know what? Let's do a countdown of, like, an hour, because I forgot to do it. You're in the US. Interesting. It's interesting how you show up in a lot of, like, European users' live streams. Anyways, okay, so all right, so the next question is question 5. So the question for this one is, it appears that the system left a fragmented message. Fragmented message. Is this going to be the last one? So there's another table in here called, like, Portbuster says, I know Panko is like Swedish, but I look for hacking related streams early in the morning. Early in the morning, huh? Interesting. Okay, so we've got a logins table, a message table, a metadata table, transactions, and users. And I get the feeling that we're going to be taking a look at each one of these tables by the end of this exercise. She streams in the afternoon. Well, I mean, she streams in the morning for North America. So for North America, she's usually on, like, around... She's usually on around, like, 10 a.m. to 12 p.m. in North America, depending on which coast you're on, of course. Okay, so schema for message. So create table message, okay, ID and part. ID and part. So there's only 2 columns in this case. So select star from message, and we're looking for a corrupted message. Shai, have you seen the new Linux LPE Fragnesia? Oh, you know, SysOS Master was talking about that. Yeah, I mean, we took a look at the, what was it? Dirty Frag. We took a look at Dirty Frag about 30 minutes ago. And SysOS Master talked about Fragnesia, which is supposed to be a related exploit. What? Hacker detected. Hacker detected. Well, I mean, this one was really easy. We just need the part. Select part from message. And then we need to put everything on one line. There's got to be something that we can do to put all of these, to put all the rows on the same line. Let me see if I can look up something. So SQL put rows on same line. Portbuster says it came out after Dirty Frag's patch wasn't sufficient and Fragnesia came out. Fragnesia does it in smaller chunks, but similar to Dirty Frag, mitigated all the servers yesterday was a lot of work. Okay, the method for putting multiple rows of data onto a single line in SQL depends on your specific database system. Usually this involves string aggregation or a pivot. So using string aggregation, if you want to combine values of multiple rows into one comma-separated list, so it's, okay, so let's just put SQLite, because we're doing SQLite, put rows on same line. Okay, depending on whether you're trying to insert multiple rows at once or display multiple rows in a single string, here are the most common ways to do it in SQLite. Portbuster says, what's the goal in this challenge? We're just answering some questions about the database. And this is... Oh, there are ads playing right now. Okay, okay. We're going to take a break. We're going to have a little water break. And in the meantime, we'll put on my favorite video. So these are the birds. They're having a little bath. We'll be back in about 50 seconds. Okay, but enjoy the birds. Okay, so ads should be over now, so we can come back and talk about how we put the stuff all on one row. So select part from message. We need to find some way to put all of these letters on the same row. I need more caffeine. Bird is real. Bird is real, yeah. Portbuster says, is there like a database of people's bird cams? There needs to be prestige in this, like who manages to get the shot of the rarest bird. I mean, if the rarer bird, then more points you get. I mean, if it was legal to hack into other people's security cameras to record birds, then maybe I might consider it. But people are going to get in big trouble if they start randomly hacking into security cameras. Okay, so what were we doing? Inserting multiple rows. We're not doing that. We're combining multiple rows into one query result, and we'd use the group concat. Oh, okay. So select, and then group concat, select group ID, group concat name as all names. What? Group by group ID. Belmong, hey. Hello, nice to see you here. Maybe group concat? I gotta work on legalizing it. It sometimes is legal. I mean, there are cameras that are intended to be accessed by like anybody. Okay, so select group concat. Part. What else do we need to do to this? So if we just run group concat without anything else. Okay. We actually get something. What if we don't want any separation? Okay, so this is exactly what we want. So hacker detected, this is the string. We use group concat, and it's all good. Okay, so let's write this up. So there is a hidden message in the messages table in the part column. And we can put the whole thing together with the group concat function. But Balmung, hello, nice to see you here, and hope you're having a good Friday. Concat function. Okay, and here is the command. Okay, and I think there's just one last question. Question 6. So hacker detected is the answer for this one. I think this has been a pretty fun challenge, especially for people who are not super familiar with an SQL. You got to learn the thing to do the thing. What is the rarest bird that you got on your bird cam? I think the rarest bird I ever got on my bird cam was goldfinches, American goldfinches. So some of these, I only ever saw them once. So you can tell the difference between a male and a female American goldfinch because one is very, very yellow and the other one is not very yellow. So the male is very yellow and the female is not very yellow. But apparently I downloaded an HTML file. That looks kind of suspicious. Highlighter birds, those are always a joy to see. I mean, it's very rare that I've seen, along with American goldfinches, we do occasionally see something like, varied thrushes. So varied thrushes are also very beautiful birds. They're also very, very shy. If you ever see them, they'll and you make contact with them, they'll usually fly away. Varied thrushes, we see those every once in a while. They look like it'd be good for barbecue. They probably don't taste very good. But anyways, the other kind of rare bird that I see every once in a while are what are those birds called? They're called only one way to find out. I mean, I kind of don't want to find out. I think I've got the name of it somewhere around here. Spotted towhees. Spotted towhees. This one right here. So these ones are very distinct because they've got these kind of scary red eyes. Pigeons are drones for sure. Crows are for sure spy weapons. We have a couple of Eastern Bluebirds. Eastern Bluebirds. Oh, these guys. These guys are, wow, they're beautiful. Okay, let's see if I can put on some new music. Anyways, let's get back to the hacking. What were we doing? So, hacker detected, right? One last question. One last question we need to answer. That one is Aura. I think they're pretty. These are these are pretty beautiful birds. Another one that's not so unusual here, but it's actually another very beautiful bird, are the northern flicker woodpeckers. So northern flicker woodpeckers, they have some beautiful plumage, and they come in two varieties, different mustache colors. So you see here, there's one variety in the east which has a black mustache, and there's another one that has a red mustache. So this is the red mustache, and these are the ones that we have in the locally. Twitch is having another stutter attack. Oh no. Okay, and yeah, YouTube is also having another bad time. Anyways, okay, we'll go back and we'll try to finish this. It appears the system left a fragmented message. Good job, we need to leave now. Okay, so we're done? I guess we're done. What's a flumage? Well, we're talking about plumage. Plumage. So when we're talking about the colors and the patterns on feathers on birds, it's plumage. So plumage is the appearance of the feathers on birds. Plumage. Okay, they were finished. All right, let's go ahead and save out. Well, there's no question 6. We're done. Okay, we will save this. Looks like a CS:GO knife. Okay, and that is done. We might be able to do one more thing today. Portbuster is on to something. Really now. Okay, so let's try as our final thing we're doing today. I haven't done like a boot to root in quite a long time. Let's try looking at Docker Labs. So Docker Labs is our favorite Spanish Docker-related hacking website. Not that we have a lot of them in the first place. So this one is a medium level. It's called Trailpack, Work Connect, Dance Samba. How about this one? How about Work Connect? Okay. So, Duck, hello, nice to see you here. I'm just doing my Friday stream. We're going to try to download and compromise a Docker container real quick. Okay, Work Connect, download. Spanish hacking is strong. I hope so. Okay, if you want to download the same thing we're doing, so are the French. I mean, I'm okay with any country. Oops, let's get out of here. Okay, so we've got the container, and we'll just call this we'll call this tab the Docker container tab. We'll give it a great color. How about some purple? And then we'll run the thing. Okay. I More Caffeine says, never heard of this, just finding sites today and plumage. Sites today and... Yeah, I mean, I use a lot of hipster... I use a lot of, like, hipster CTF platforms because I'm looking for alternatives to TryHackMe and Hack the Box. Well, mostly because the stuff that I can cover on Hack the Box that is available as evergreen and free is kind of limited. Except for Imagination Land, that country can go back to this this guy. Okay, so done. We can run the auto deploy script, and hopefully the auto deploy script doesn't destroy my computer. So when you're dealing with any script that you get from an arbitrary place, you might want to run the script, well, either manually review the script, but if it's long, it's kind of a pain in the butt. This one's also in Spanish, so it's harder to enumerate. This is a great use of AI. So if we go into AI and we ask it to look over a script, look over this bash script, and make sure it doesn't do anything malicious. Okay, and then paste in the bash script. Okay, reviewing the bash script for any suspicious behavior. What model are we using? I'm not sure. Let me take a look. So completed in 2 steps, does it tell me which model it used? Because I'm using Perplexity AI, and Perplexity AI has a bunch of different models it uses. So I've got it set to best, so it's going to use... I'm not too sure. I guess because this is a coding thing, it might default to like some sort of Claude. Okay, so the script does not look overtly malicious, but it is not fully safe to run blindly because it performs privileged system changes, removes Docker images and containers, and runs an untrusted Docker image from a tarball without hardening. Okay. So at a high level, the script prints a banner, checks the OS architecture, optionally warns Mac OS users about Docker networking, ensures that Docker is installed, and loads a Docker image from a .tar, starts a container from it. Okay, so I mean the reason why I'm okay with running the scripts, the auto deploy script from Docker Labs, is because Docker Labs is it's run by a famous Spanish YouTuber who does cybersecurity content. So the famous Spanish YouTuber that does cybersecurity content is this guy over here, El Pingüino de Mario, and he's got a pretty big YouTube channel. If he was associated with some sort of malware, then he would take a big reputational hit. Okay, ATP might as well use Sonnet 4.6 for free instead of paying those Perplexity scammers. I mean, I'm using Perplexity for free. One of my viewers got me a deal where I was able to put in like a coupon code for a year of free Perplexity, so that's why I'm using it. Shin BDR, hello, nice to see you here. Hope you're having a good day. Okay, so let's go ahead and run the Docker script. Let's see. No. It's just run autodeploy.sh. We need to make it executable first. Oh, we need to specify the tar. So workconnect.tar. You got the free Perplexity as well? Good to hear. Okay, so now we've got our vulnerable Docker container running on this IP address. So 17. I mean, this is a pretty standard Docker IP range. A year free is pretty good, but the limits are a bit of a pain. I haven't run into too many of the limits. But anyways, we'll call this one our port scanning tab. And we'll just run some nmap. I haven't run nmap in a while. By the way, if you have a cloud account, you can use Sonnet 4.6 for free, and $20 a month for frontier models like Opus. Yeah, I've heard a lot of good things about Claude Code, or like Claude's like coding capabilities. Although I don't really do all that much coding, but it's still good to know about. Okay, so this is port 8000. Uvicorn. What the heck is Uvicorn? And can we abuse it? So, I Need More Caffeine says, I think the student discount is also great in comparison to most other pricing. I haven't been eligible for student pricing in a long time. But, I mean, good for anybody who's able to get it. Uvicorn. What is this thing? We'll call this our research tab. And the research tab has to be yellow. Them's the rules. Okay, so since we know that this is running a web page on port 8000, we'll check it out. Okay, so this one's called... El futuro de la carrera empieza aquí. I hope I didn't offend anybody who speaks Spanish. But check me, I think it's more like in Python HTTP. Uvicorn is a Python HTTP like server type thing. Okay. So Work Connect is here. We just need to make sure we can register for an account, it looks like, and we can log in. We can log in, we can register. Is there anything hidden in the comments? Doesn't look like it. When I see Uvicorn, I think SSTI, Ginger. Oh, really? I haven't really encountered it before, but I mean, if it's a Python web server type thing, then yeah. It might be vulnerable to server-side template injection. Okay, so I think what we want to do is we want to register for an account because it's an option. Okay. So they're looking for an email, they're looking for a name, they're looking for a document ID number, and then looking for like a password. Okay, so I don't know, HackerFrogs, hack@frog.com. They're looking for an ID number. I don't know, how many digits does it want? Okay, I know what went wrong. Unicorn, Ruby on Rails web server. Uvicorn is a Python web server. Okay. Maybe based on that. Okay, so we need to set a password. Very secure. Registration complete. Initiate a session. Okay, great. So we will log in. Oh, we need to do it by ID number. Good thing I remember it. Okay, log in. Work Connect. So this is a fully functional app. So maybe there is a known vulnerability for this thing called Work Connect. So we'll search exploit Work Connect. Nope. Unicorn. Okay, so this is a bit of a pain because we need to translate everything. Translate page from Spanish to English. Okay, close session, start session, sign up. Sign up. Okay, we got our usual links over here. So we got profile, my offers. So we can upload a photo. So this might be a file upload attack. And what else do we have? We got security. We can upload a profile photo. So something, I mean, we probably want to test the system for faulty file upload. What's in our preferences? So the preferences and the security look about the same, which is kind of weird. We probably want to start up some Burp Suite so that we can take a better look at the requests that are being sent back and forth. It's burping time. I haven't started up Burp Suite to do any real web app stuff in a while. Kind of miss it. Proxy, open browser. Okay, and we'll open it up in Burp. Check the session first. I completed the network basics on TryHackMe and built a Python application to encrypt words by giving it a word. It's PFP. Which PFP are we talking about? Okay, so wait. I'm not logged in, but I still have access to the dashboard. This is no good. You shouldn't be able to log into the application without a username and password. This seems a bit suspicious. Diabolical developer even gets stuff right. Tasty security bugs. All right, well. Let's try to upload something. So let's see. We can upload a photo from an external website. That can't be secure. Okay, let's try. Let's try hosting our own server. So we'll call this our localhost services. And we'll give this another funky color. How about some orange? It's never a problem. No, never a problem. That's why it has to check the session. Definitely secure. The S in HTTPS stands for secure. There's no HTTPS here. And it says not secure over here. Anyways. So we probably want to host like you probably want to host some sort of JPEG file. So locate 1x1. So we'll probably grab like a 1x1 JPEG file, maybe a PNG. Yeah, how about a JPEG file? Okay, so we just grab this, copy it to our current directory. And then we will start up our Python server. And okay. And then we can try uploading this. So the other thing we need is we need our IP address. So our IP address from the Docker container, or for the Docker container rather, is this. Where'd it go? There it is. 172.172.17.01. So that would be HTTP / and it's, what's it called? Example image 1x1.jpg. I love how the frog does an ollie with the keyboard sometimes. Well, I mean, it's just going nuts on the keyboard. Okay, so this is my JPEG that we're going to try to upload. And let's see, we will put in this. I have no idea what happened. Did we actually make a request? Proxy HTTP history, upload, post, dashboard, update profile. Okay, so let's put this in the repeater. Okay, so full name equals target plus user, email equals this thing over here, bio and photo URL equals this. When we send this request, it comes back as okay. And what does it render as? Huh, interesting. Wait, let's look down at the bottom there. Okay, so we get in HTTP 1.0200 OK, simple HTTP, oh, no, this is our server. This is our server that's responding. Simple HTTP, yeah, Python 3.3.17. And let me just double check my version of Python, 3.13.7. Python -- version. Yeah, this is ours. Okay, we got ads running on Twitch, so when ads run on Twitch, we also put on the birds. So this is the varied thrush that I was talking about. He doesn't show up for very long, but enjoy the birds. I'm going to take a little water break. Put the birds away and get back to the hacking. Dan Soy. Hello, nice to see you here. Do you do bug bounty hunting? I don't do bug bounty hunting. I know some people who do bug bounty hunting. I don't do any bug bounty hunting myself. Okay, the birds. Finally, we learn how to hack NASA, Facebook. Well, I mean, the birds know how to hack. The birds are the ultimate hackers. Otherwise, how do you be able to fly? Anyways, let's start up our session. So we'll log in as our user. No, here? Yeah, here. Okay, so let's see. session, and then password. Loving birds has everything to do with hacking, of course. Okay, so save password. No. Okay, and then we can. Let's see if we can upload from here. Okay, reload our profile. Method not allowed. Update profile, method not allowed. Why did it redirect me to update profile? And am I logged in right now? Because it doesn't seem like I'm logged in. Let's try logging in again. Huh. Are we not able to change our stuff? Let's just try changing our user information first. Let's see. HackerFrog. And our electronic address is hack@frog.com. We got him, boys. Yep. What are y'all hacking? So we're just trying to hack like a vulnerable Docker container that we got from over here, dockerlabs.es. These are hacking exercises. Okay, professional title, chief hacker or lead. Let's see, manager of the Department of Web Hacking. Sure. What time is it there? What time is it here? It is 7:30 where I am right now. Okay, so let's go ahead and update this. Does it update? It didn't update. It didn't update. I guess... Do I not have a user session? Hold on. Proxy... Post to login? So this is a redirect to dashboard. I don't think I got logged in. It's 7 p.m. over here. You can use Netcat to listen and try to access that from the upload image. Maybe you have information on how the server reaches your box. Yeah, there's no. We didn't get a cookie. We got to the dashboard, but we didn't actually establish like a session. What? Yeah, so I'm not exactly too sure how we're supposed to tackle this. Because the profile updater over here, we're sending this without a cookie. So because we don't have a cookie, we're not actually. I'm not actually sure if we're modifying anything or if we're writing anything. I mean, it sends everything back okay, but we're not logged in. Let's take a closer look at this thing. Okay, so we need to log in with our number, with our, like, I don't know, with our identity number, with our identity document number. We got a registration page. You know, maybe I should just do like a fuzz. Or maybe Work Connect has like a GitHub like repository. Okay, so Work Connect, GitHub. Okay, a platform for HR professionals to something. I'm not too sure which one of these GitHub projects is going to be what I'm looking for. Okay, Smiling Proud says, I'm more confused watching. What do you need clarification on? Let me know. I was thinking maybe some file read somewhere? Maybe. Maybe the server has a cookie on... maybe you need to use netcat. So Work Connect, a platform for HR professionals to something. Okay, let's take a look at this. We'll take a look at a couple of Work Connect. So this doesn't look like what we're looking at right now, so let's try another one. So there's a possibility. And this doesn't look like it either. Okay, let's do some fuzzing. So what we're going to do is we're going to grab the IP address over here. Oh, latest was a lie is also associated with this. Okay, I need to go in and adjust my etc host file. Okay, so we're going to do a little bit of fuzzing. Let's make a terminal for it. Fuzzing. Then we'll do some... let's just run some derb first, because it's nice and fast. Huh. Error connected to host. Oh, yeah, we need to specify port 8000. We're just trying to figure out which endpoints exist on the target. So we know that there's a login endpoint, and there's also the landing page here. So is this index.php? This is not PHP. Okay, is this HTML? This is not index.html either. Ignore server hungry. Server wants cookies. Does it want cookies? Okay, so we found the dashboard, and the dashboard doesn't require you to be logged in. There's also docs. Okay, that's good. We should probably check out the documentation. Ah, okay, so this is our API endpoint. Maybe JSP? I don't know if JSP would be... Okay, so we've got our API documentation. So we've got dashboard update profile, get dashboard, post login, register. We've got our landing page. Okay, so when we register our user, maybe we can fast API, my beloved. I mean, I don't know about fast API 010. I wonder if there's There probably are not known vulnerabilities for this, are there? Fast API 010. Nope. Anything for Fast API in general? Nothing here. Von Bork, hello, nice to see you here. That confirms Uvicorn and Fast API. Flask over Fast API, okay. That's the API's, oh, it's the API's version, okay. What was I looking at? Oh, this thing. Okay, so the landing page, so it looks like we've got all the endpoints here. Schemas, body, login, post, login, body, login, post, login, post. So we can DNI string and a password. Register, register post, register post. Post register post is looking for name, email, DNI, and password. We also have a update dashboard. So full name, email, bio, and photo URL. We got HTTP validation error. And more validation errors over here. What's a DNI? Is this a database thing? I think this is some sort of like national identification number. Because they reference it over, where is it? Over here. So when you try to register, they ask for your Documento de Identidad, or the DNI. So this is, yeah, some sort of ID number. Do not incriminate, of course. It's got to be it. So we got our name, email, DNI, password. I think, well, I mean, our server was being accessed when we updated our profile picture. But whether or not we can turn that into some sort of file upload attack, we need to figure out where the files are being uploaded to. So we found docs, login, register in static. Static was a 307. I wonder where you go to if you go to the static endpoint. You just get an error message. Okay. It only makes require head. That's interesting. Okay, so let's run a more thorough. Let's run a more thorough directory busting attack. So we'll try some GoBuster. On port 8000, of course. Okay, we'll look for them some HTML, PHP, TXT, zip, back, JSON, XML, RAR. Okay, let's see. That's what I said before. First check the requests from the server to see if it's using PyCurl. If it's using PyCurl, then you can use the schema like file to get LFI. Okay. Oh, what is this? No such host. Oh, I misspelled it. Silly me. Okay, we're finding some things. We'll just leave this running in the background, and yeah, let's go ahead and run some curl. Okay, so this is Uvicorn. Uvicorn, yeah. Content length, content type, text HTML. Uvicorn server, so that's Python. Okay, login, register, doc, static. This is going to take a while. Well, this is going to take a really long time. Maybe I should have gone easy on the extensions. Let's try running some... what's the name of this thing? What's the name of that that vulnerability scanner that everybody likes to use? I keep on forgetting the name of it. It's called like Genesis or something. Nikto? I mean, Nikto's not everybody's favorite vulnerability scanner. Not Nikto. It's Nessus? Not Nessus. It's Netcat your local Docker. Netcat your local Docker port 80. Oh, I mean it's not port 80, but I mean we could netcat the thing. Forward host lookup failed, unknown host. Unknown host. Oh, no. Yeah. Still says unknown host. Oh, no. Netcat has to be... We don't put HTTP there. Yeah. And then we get bad request. Let me see if I can figure it out with like a search. Modern web, modern network vulnerability scanner. Okay, Wiz, no. Nuclei, that's the name of it. It's called Nuclei. Okay. Then upload the image again. No, you need to listen. My bad. Sorry. Pardon me? What's the name of the terminal that you're using in order to switch between tabs? Unicorn versus Gunicorn. Let's see. Have you covered Nginx as a gatekeeper yet? Nuclei, the one next to Nikto in my brain. Yeah. Okay. Upload Netcat your local Docker IP on port 80, then upload the image again. I'm trying to understand. netcat your local Docker container, and then try to upload the image again. It didn't find anything. Oh well. Okay, so still haven't found anything substantial with the web app fuzzing stuff. Okay, what does nuclei do with the templates? So the templates are used to identify vulnerabilities. That's, I mean, that's what I assume it's trying to do. Let's see what happens if I give it port 8000. Okay, any more caffeine says, I think Henki is asking to run netcat listener on your local machine. Run a netcat listener on the local machine? Okay. Listen on port 80 on your box. Listen on port 80 in your box and then try to upload the image, and you'll get information on how the server reached your image. How the server reached your image. Oh, okay. And then make the upload request to your listener. Okay, well, I mean, I could try that. Thank you for explaining it to me again. Okay, so netcat NLVP localhost. Well, netcat NLVP port 80, and then run the same update profile thing. I think it was this one. Yeah. Okay. Send that. Connect from unknown. Right. Head request to this endpoint. See if you can get a banner on the service. They're connecting to me via curl. So it's, that is PiCurl. I mean, I've never really dealt with this vulnerability before. So this is new to me. Okay, I think I can do another 30 minutes of this, and then I have to go. But let's see if we can make some progress in the next 30 minutes. Okay, so they're using curl. That's using curl. You can abuse that. So what do we host? If it's trying to use curl, then how do we get the hack off? So do we have to host some sort of malicious file? Maybe I can do a little bit of research. PiCurl upload exploit. Anti-curl as a straight iron. Anti-curl as straight iron. Okay, so let's see. The term PiCurl upload exploit typically refers to exploitation of an arbitrary file upload, vulnerabilities in web applications that uses Python's PiCurl library for client-side transfers, or the abuse of PiCurl, so that's arbitrary file uploads, client-side RCE. Applications using PiCurl to process or upload files can be vulnerable if they did not validate the file type or if the destination directory has insecure permissions. If an attacker forces the application to upload in an executable script, PHP, JSP, or Pi, into a web accessible directory, it can lead to remote code execution. So an application accepts user input like a profile picture, but fails to sanitize the file extension or bypasses MIME type validation. So the Python script routes the file upload to a remote server using PyCurl, postfields, or HTTP put. If the server stores the uploaded payload in a directory with executable permissions, such as an uploads folder, the attacker can access the uploaded file via the web browser to trigger its execution. So I think what we need to do is we need to figure out where our files are being uploaded to. Okay, we're getting timeouts here. Okay, so the problem is that if we don't know where the uploaded files are being put, then I'm not sure if we can actually exploit this. Okay. Uploads directory does not exist. I mean, the other thing that that is really interesting is that we've got the API documentation here. Update profile, dashboard update profile. So this is probably being sent as an API request via the browser, right? So we got our proxy. We've got our dashboard update profile. Bird time. Oh, it is bird time. Thank you for letting me know. Let's put the birds on. How about some... How about the woodpecker gang? Okay, we'll be back in about 30 seconds. Okay, local Ken. Hello, nice to see you here. What is up? Hope you're having a good day. All right, so openapi.json. Okay, so there's a link here, and oh, interesting. Okay, so the path is over here. So this is OpenAPI 3.10, Fast API version 0.10. Remember to keep track of the curl version. Oh, that's a good point. So this is curl version 788.1. Okay, so nothing for this particular version of curl, but there is some. Let's look back. So register page, register post, validation error, login page, login post. Dashboard page, update profile, validation error, body login post, login post. Okay, so let's see. Henke says maybe the curl abuse is serving the Python reverse shell and piping that to Python on the URL like http rev pi pipe into Python. Serve the Python reverse shell and then pipe that to Python on the URL. Let me think about that. So we might provide something like a rev shell. So rev.py and pipe it into Python 3. So this is like some sort of remote, like OS command injection. So what was that? What's the meme? It's like curl into bash. Curl bash, right? So it's kind of similar to this. But what was I mean, we would need like a Python reverse shell to get this working. Revshells.com, get one from there maybe. Okay, so Python 3 shortest. Python import ospty socket something something bin bash. Well, I mean, we can try this. Rev shell is the goat. We will see. Let's see. Call this our regular text editor. Okay, so this should be fine. This should be fine. We'll just save this out. Tomato, tomato. Okay, and then we'll host this. Let's see, localhost services here. We'll just do some Python web server here, and then we will set up our netcat listener over here. Actually, you know what I want to do? I want to try out Penelope. So people tell me that Penelope is supposed to be this really great reverse shell tool. Penelope is fire. Test locally first, maybe quick sanity check. I mean, maybe, maybe not. Penelope, port 443. Okay, we'll give this a try. And then we will... do the profile update over here. Okay, so the photo URL is going to be rev.py pipe into Python 3. I mean, we'll see if it works. Okay, did we get a byte on our localhost? Okay, it ran head on rev.py. So it did try to access it. Oh, interesting. We got some sort of error here. Okay, syntax error, leading zeros in decimal integer, literals not permitted. Prefix for octal integers. So maybe we need to URL encode this. So this character right here was not URL encoded. So we will convert selection URL encode key characters. Oh. URL encode all characters. Okay, and then we'll send it again. We got the same error though. Syntax error, leading zeros, something something. Let me copy this whole thing. So it tried to run this as Python code. I think that's what happened. So this response from my server was so this was one of my headers, right? The vuln is not there. It's using head to reach and print that head so something is reflected in the header of the response. Okay, so if it goes through successfully, actually let's just try sending this without. So if we just send rev.py, oh, okay. So if we just send rev.py, then we don't get the error. It's because we tried to pipe it into Python. We tried to run Python. We ran Python 3. So could it be? This is what it got stuck on before. It tried to run this as Python code, and that led to a syntax error. It's more complicated. You need to serve Python that returns some modification header. Some modification header. I mean, what happens if we just pipe it into anything? What happens if we just try to give some sort of OS command? Maybe it just fails. So just pipe this into who am I? Or I don't know. We'll try URL encoding this. Wow, it worked. It worked. So we are recruiter. No. It worked. That's really big. It's gonna be hilarious if you found something totally unexpected. Yeah, I mean, we managed to get RCE. So we're the recruiter user. I mean, we could confirm this by doing like a hostname command. And then sending that. Yeah, so hostname is some like, random letters and numbers. That's pretty typical for Docker containers. So we just need to send ourselves like a bash rev shell or something, right? Actually, can we do something more complicated? Like which %20 busybox? There's probably no busybox. This is a Docker container. Actually, which we know that it does have Python 3. Okay, nice. Reals. Civil engineers would love to hear that. Jurassic Park. Oh, it's all one word. It's all one word, Jurassic Park. Give it a try. Really shows how we overcomplicate often. Okay, user bin Python 3. So we can probably use like a Python 3 rev shell command. But
it's a Unix system. I know this. It's all the files of the whole park. It tells you everything.
It tells you everything. Yeah. I mean, if I can get my rev shell before I run out of time, I guess I'll call that a win. So what do we need to do? What I want to do is I want to typically like my best results. My best results are uploading a rev shell binary, but you know what? Let's just use some quick and dirty like bash. So it's like bash rev shell, bash-i, and see if this works. Of course, this is chock full of special characters, so I don't know if this is going to work. Okay, so, hey, Neems, nice to see you here. Okay, so we'll convert the key characters. Okay, and then send this. Did we get a response? No, we didn't get a response. Okay, so because we've got all these special characters in the payload, let's try uploading a reverse shell binary. So we'll do MSF Venom. You could use PWD and encode all the characters. Use PWD to get the path. Let's just try. Let's just try this first. So the other thing we could do is we can do a little bit of reconnaissance right now. So we could run something like I don't know. Yeah, we could run PWD or LSLA. So this is opt work connect. Opt work connect. And I guess we could also try like creating a file. Just creating a file to see if it shows up. So touch %20 test, and then send this. Okay, and then we will do ls to see if it showed up. Yeah, okay, it showed up. Okay, and let's see. Encode all the characters. See, you have to go now. Thank you very much for letting us know about the PyCurl stuff, Henky. I don't think we would have made any progress without figuring that out. Thank you, Henky, and hope you have a good day. Okay, so so we know that we can create files in this directory, so we've got write permissions. So I think we should just do like a wget command. wget http, well, the same address over here. And then we're doing rev.elf. We will URL encode this stuff. Okay, and then we'll see if this works. Send. Actually, there might not be wget. Yeah, there's no wget on this system. Okay, well, wget isn't going to work. How about curl? They might have curl on the box. Which curl? So there is curl. So how do we save out with curl? Curl -o, curl URL o file, curl URL -o file. Okay. See if we can get this working. -o file. Okay, so we just need to URL encode. Well, the spaces where you can URL encode is %20s. The dash, I'm not too sure what that URL encoding is. I'll figure it out here. Convert selection URL encode %2d. Okay, and then we're not running wget, we're running curl. Couldn't use that plain photo URL to upload anything. The plain photo URL, I mean, we don't know where it gets uploaded to, so it doesn't really help us very much. The %2/ is going to cause an issue, is it? Where's that? Oh, this. Okay, so we'll URL encode the / as well. Okay. And let's send it. So what happens? Could not resolve host. Could not resolve host. So 172.17.01 %5 something something. Okay, so what happened here? Could not resolve host. Maybe we do need to just do it like this. Okay, we'll send it again. Drop the %2. Okay, I think it worked. I think it worked if we look at our local hosts. Yeah, we did get a GET request to rev.elf. So all we need to do now is we just need to make it executable and then execute it. Okay, we're very close. What does erroneous mean? Erroneous means wrong. So we just run chmod 777 on rev.elf. So nothing, yeah, so nothing comes back from that. That's pretty normal. So chmod, and then we need to run the file. So it's just /rev.elf. Send that. Okay, so it looks like it hung. If we take a look at a remote access tab, we got a session. Hey, we're awesome. Who am I? Recruiter. Okay, we've got our rev shell. So I guess we can call in Mr. Scary Hacker Voice Man before we wrap up for the day. At least it's not multiple sources. Erroneous means in Latin in error. Okay. So I haven't called in Mr. Scary Hacker Voice Man in a while. Let me call him in, then we can talk about how we got into the box. I'm going to be improvising this. Wish me luck, everybody.
Hey there, everybody. It's me, Scary Hacker Voice Man. Scary Hacker Voice Man comes in every time we break into a system. And we just broke into this one. Well, Mr. Work Connect Administrator, it seems like you enjoy implementing Python curl into your web applications. That is a big mistake. We were able to take advantage of your Python curl command to leverage it into remote command execution, and then we use that to upload and execute a reverse shell binary. Maybe you knew about those flaws on your system, or maybe you decided to accept the risk. Well, you accepted the risk. And now? Now we're in.
Okay, we managed to get into the box, and well, thank you very much to Henke for suggesting looking up the potential of the PyCurl stuff. So we managed to get in. We're the recruiter user now. Now we need to elevate our privileges and completely own the box. Unfortunately, I don't have enough time to do that tonight because it's already past my dinner time. I'm so hungry right now. Okay, technically it's an arbitrary command execution, not remote command execution, not remote command execution. It's a OS command injection. So it's an OS command injection through the what is it called? The file upload endpoint. Yeah. Anyways, well, I mean, thank you very much for coming to today's stream. Let's talk about what we're going to be doing next time. So we've got a schedule for next week already set up. We're going to be doing AI basics. We're going to be doing some Volnix boxes over there, more digital forensics. We're We're going to be doing more demos for PicoCTF. It's kind of both because it's ACE from a remote endpoint. And on Friday, we're going to be doing Windows stuff. After a really long time, we're going to be doing more Windows stuff. We're going to be doing TryHackMe Intro to AD Breaching. And then after that, we're going to be doing HackSmarter stuff. So HackSmarter's AD challenges, we're going to be trying out some of those. It's going to be a lot of fun. So please come by on Wednesday and tune in for all the fun. So before we go, let's see if we can find some people to raid into over at infosecstreams.com. And hey, thank you, SysOS Master. Really appreciate it. Let's see. It looks like I'm the only person on InfoSec Streams that's streaming right now. But let's see if there are any other fun people on Twitch right now that we can raid into. Raid the Shy Hat. I mean, I wish I could. Okay, it looks like Moohoodles is streaming right now, so let's raid into her. She's always a lot of fun. She talks about NASA and space stuff, so let's go ahead and start that raid. How do you spell that name? I think this is it. Okay, everybody. I hope you have a great weekend. Of course, we're going to be back on Wednesday of next week. Hope to see you then. But until then, thank you very much for coming on by. HackerFrogs out in 5, 4, 3, 2, 1. Actually, wait. Remember to give this message when you arrive on Moohoodle's channel. So it's hip-hop hack like this. Just like that. All right, everybody. HackerFrogs out in 5, 4, 3, 2, 1. Happy weekend, everybody.